The first question we're going to look at is table to linear equation level 3. This is when you take a table and you want to make it a linear equation. Once again, if you do not remember the formula, you can definitely pull that up. All right, guys, so this is a recording going over the interim review, unit 1, 2, 3. What you're going to first do is split your screen. Please go to the 2 boxes on the corner there. Don't press it, just hover. And then you want to say, hey, go to the left side. Then what you want to do is open a tab and drag it to the right side. And what we're going to do is go to Desmos Graphing GA. Desmos Graphing GA test. What that's going to do is give you the exact calculator that you're going to have access to the entire time. So Graphing Calculator Georgia version, that's what you're looking for. Make sure that it's green and it says Georgia version. Now you're in the right spot. So we're going to go ahead and get started. Before I start, I do need to introduce you to your formula sheet. This is going to be in your testing site every single time. There should be buttons at the very top where you click it and then you can see it. So I'm definitely going to use that as well so you can get used to it. The first one I'm going to go over is table to linear equation. All right, so here is an equation of a linear function. So it says linear. All right, so that's the key word that you're looking for. So if you have no clue what to do, you're going to look for that keyword in your formula. And you can see that it says linear equations. Which one is something that you recognize? Well, you should recognize this one. We've done this 1,000 times, right? So what it's saying is, I want to take this table and I want to make it look like this. No problem. You go into your Desmos calculator. I need to put in the table. You're going to press this plus sign. See, it's going to add item. So look, it says add item. What do you want to add? A table. What table do you want it to recognize? And you're going to copy every number. You are not going to be lazy. You are going to copy every single number. And then you are going to make sure that at the very end, you double check it. All right, so boom, there it is. Now I need this to be linear, right? So I need it to look like y equals mx plus b. I did teach you how to do y1 squiggly line, but now that they have included this button, we don't have to do that. We're going to press this right here. See how it says linear? If you want to change it to something else, you can. But because it says linear in the question, that's what I want. So this is your linear equation, y equals mx plus b. That's all you got to do. So you're going to take it from there and you're going to type it in here. Y equals -4 plus 4. X. So clearly, make sure you copy correctly. Again, make sure you type it exactly as you see it. Then you... And perfect. I'm good. If you get it right, you're going to leave the data sheet blank. If you get it wrong, you're going to put an X by this title. So here's my data sheet. Here's my first title. I got it right, which means that I leave this box blank. If I got it wrong, I'm going to put an X. So again, if you got it right, you're going to leave it blank. If I don't know or I got the question wrong, I'm going to put an X. And again, this is all done without notes at this point. I'm going to take a look at writing equations of lines. So I'm going to click on that. Write an equation. So you're writing an equation of the line fully simplified in slope-intercept form. Again, you have no idea what that means. You come right here. Oh, look at that. Slope-intercept form. Looks exactly like y equals mx plus b. So you're writing this line in y equals mx plus b. In order to do that, what you're going to tell the calculator, because you know how to do it from a table, is you're simply going to make this a table. I need you to find 2 corners. So I'm going to put table and I need 2 points, 2 corners. Okay. Now in Delta Math, it kind of cheats because it gives you a corner. But remember, let me zoom in a little bit more. A corner is here, 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 and here. Where does that blue line pass a corner? Is this a corner? No. 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 This a corner? Yes. Okay, so again, you're looking for 2 corners. So Delta Math is going to give it to you, but on your test, they're not going to give it to you. Once I find the corner, I need the X and the Y. So I look at the X because this says X, X. So I look at the X, this number is 4. So I come and put 4. I look at the Y for that number, it's 10. Y is 10, I put 10. That is 1 point. I need 2 of them. So again, Delta Math gives it to you. However, on the test, it will not. So here's another corner right here, -4 and 4. So x is -4 and y is 4. Once you have 2 points, remember what you're looking for is y equals mx plus b. And since they've added this button for you, you don't even have to do any work. You're going to click this and you're going to say, I want a linear regression, linear being the key word, because this is in y equals mx plus b. This is your answer. So I'm going to Control C, Control V. Here's the one problem. I don't think it's going to accept decimals. It might not. So I'm not going to put it as decimals. How do I make this into a fraction? I'm going to come to the next line and write the decimal down. And as soon as I write the decimal down, I can make it a fraction. So this is 3/4. And if I do this correctly, you're going to see that it will still match everything. So once again, my purple dots, my linear regression line, and the answer that I'm putting in all match. Once I do that, I know that it matches. I can copy the answer into my answer sheet. All right, so you're gonna go ahead and submit. Yay! So that's the second question. Moving on to the third question, graphing lines from equations. All right, you are given an equation this time, and you are asked to graph it. So let's go ahead and put our equation into decimals for us so that we can just see what it is. So this is y equals 2x minus 1. All right, to graph this, so I just need to copy this here. You can see that it goes from 10 to 10. So I'm going to zoom in and I'm going to hide this because I don't need it. Zoom in until I see it going up by 1. See, 1, 2, 3. 1, 2, that's what I need, okay? It's going up by 1. What I need to do is find the corners. So again, this is right here, this way. This is a box. This is a corner, this is a corner, this is a corner, this is a corner. So where is the line going through one of those corners? So I'm going to start with this box right here. Do you see the line going through one of the corners? Yes. This is not a corner, but this is a corner. And if it is a corner, if you move your mouse ever so slowly, you'll see the 2 points. So I need to go graph it at 1, 1. It always goes X and then Y. So I'm going to go 1, 1. Then I need to find another corner. Is this a corner? No. What about this? Yes. Every time I think I get to a corner, I just move it so slowly just so I can see the number. X is 2, Y is 3. X is 2, Y is 3. And I'm just going to keep repeating this process. I'll find one more. So boom. Is that a corner? No. Is this a corner? Yes. Anytime I think I get a corner, I just move my mouse slowly over the point I think it is. And I can see it as 3, 5, but it keeps moving. So 3, 5 would be another one. And if I've graphed this right, if I go to 3 and then 5, you can see that that's also a corner right there. Okay, so once you are sure that you've graphed it, I'm going to zoom out real quick. Does this look like it could be right? Yes, because if you look at this space right here, there's like a little triangle right here. See that? There's like a little triangle right here. And that's how you need to double check your work just to make sure you copied it correctly. Once you're sure that it looks the same, and again, you can just minus here, plus here, or you can do what I'm doing, which is Control minus, Control plus. Once you're sure it looks the same, then you can go ahead and submit. Please do not submit without looking at the entirety of the shape. All right, guys, we're going to take a look at solve for input of function given output. And put my decimals calculator back. It says, given the function f of x is equal to negative x minus 5, solve it for x when f of x is equal to 4. Miss Ainley, I don't even know what to do. All right, that's okay. Go ahead and type in the question as you see it. That's what's going to be your first line of defense whenever you don't even know what you're doing. Just type in the question. So I've typed in the question. What am I trying to look for is when f of x is equal to 4. Let me see if I can ask the calculator. Hey, calculator, when is f of x equal to 4? Okay, it's not telling me because it said f of x. All right, so my x is unknown, but I know my y. Let me try something else. What else can I do in the calculator that will give me numbers to where I can see my y value being 4? Table. So if I click settings, table, I'm looking for my y value to be 4. Now, it's saying something is wrong because I've defined f in more than one place. Okay, I have 2 f's is what the calculator is confused. I'm going to delete one. Okay, so now it's a table. I'm looking for when the y value is 4. So I don't have the y value being 4. That's okay. I'm going to come to the last one, and I'm going to press enter. And all of these numbers are now going bigger in the negative direction. So I'm going in the wrong direction. I need to really go up here. So what I'm going to do instead of typing in bigger numbers, I'm going to type in smaller numbers than -2. So I'm going to go in the other direction. So -3. That doesn't work. -4. So I'm just going in the other direction. -5. And -6. You can see I'm getting closer to 4. -7. -8. And of course you can guess higher. -9. Boom. When x is -9, y is -4. So when x is -9, y is +4. I'm going to do another one of these just in case, because that one maybe is a little bit tricky for you. I don't know. So I'm going to do another one. Again, I'm given an equation. Anytime I'm given something, let's just go ahead and get in the habit of putting it in. Maybe it'll, jog our memory. So -3x minus 5. All right, I want to know what is the x value when y is -2. All right, so again, I'm going to make it a table. And I'm looking for the y, which is right here, to be -2. And there it is, -1. So it's just a matter of matching from your table. We're going to take a look at evaluate functions mixed representations. What that means is many ways of looking at things. Okay, so when you have the mixed representations, how do you evaluate the function? So first it says find g of -2. The letter is g. So do I look at h? No. Do I look at f? No. I'm only looking at g. So first I identify which function I'm looking at, which is this graph. Now that I'm at this graph, it says go to -2 on the x because it's in the parentheses. So here's the x, here's -2. Then how do I find my value? I go up to the graph, and then once I hit the graph, I go to the right, and f of -2 is 7. So that is how to evaluate from a graph. I'm actually going to do a few of these. This is h. Do I look at g? Absolutely not. Do I look at f? Absolutely not. Do I look at h? Yes, I do, because it's asking what is h of -9. And again, -9 is inside the parentheses, so I'm looking at the x. So I'm looking at h, the function h, but I'm looking at the x one. And so I go with -9, which is right here. What is the y value or the output when x is -9? -3. So this one is not even a Desmos question. It's just using our eyes. All right, let me do another problem. This time it's asking for f. So that's from a graph. I've already done a graph one, so I'm just going to go to the next one. This one's asking for g. G is a table. I've already done that. So I'm looking for one that's asking the equation, and this is it. So again, g. I do not look at h. I do not look at f. I only look at g. Now, since I've established that you know how to evaluate from a graph and you know how to evaluate from a table, what we can do is put it in Desmos so that we can do just that. So you're going to type, when you have an equation, you're going to type it into Desmos and either look at the graph or the table, whichever one your preference is. So I'm going to type it in real quick, and you can type in the g of x. It just makes it a little bit longer. I'm just going to start after the equal sign. So Shift 6 is going to bring it up here, or you can press this arrow and click one of these buttons. And then -x minus 4. Always double check to make sure you copied exactly what the question is. I did. Now we've established I know how to do it from a table. I know how to do it from a graph. Well, here's a graph. And I can zoom in and look at exactly what I need, which is g of -4. So -2, -4. There's -4. So I'm going to go down until I hit the graph, and I'm already going for too long, but it's okay. All right, I think I hit it around here. So boom, there it is. So -4 is equal to -32. So when I go this way, I'm going to get -32. That's too much work. So instead of doing that, I'm actually going to do it from a table. So to make it a table, I click settings, table, and I want g of -4. So if it doesn't have -4, I can go ahead and just type -4. negative 32. So you get the same answer as I did on the graph. As a matter of fact, you can see just zoomed in to exactly where it is on the graph. So now that you know how to evaluate from a graph and from a table, the only difference with an equation is type the equation in and make it a table. All right, so this one is going to be negative 32. And that's how you evaluate given different representations. So whether the question gives you a graph, an equation, or a table, you should be able to evaluate. All right, we'll take a look at write equation given a linear situation. Write an equation given a linear situation. All right, with this one, you just need to really find two things. You know that you have a number that happens one time, and I'm going to show you from the formula sheet. All right, so we've been talking about this for a really long time. You have y equals mx plus b. B is your y-intercept, the number that happens one time, or your start, or your initial. And then m is the number that is your slope. It's the number that keeps happening over and over again, every hour, every year, every day, every something. All right, so once you know that, that's what you're looking for in your question in order to write your equation. You just need to know what m is and what the y-intercept is. So I'm going to read this question. I'm going to highlight when I get to a number, okay? At the end of a snowstorm, Angel saw that there was a lot of snow on this front lawn. The temperature increased and the snow began to melt. So that's going to be important at a steady rate. There is a depth of 18 inches. Okay, boom. There is a depth of 18 inches, so that's my first one, of snow on the lawn when the storm ended, and then it started melting at a rate of 1.5 inches per hour. So there are my two numbers. So remember, I said you're going to have two numbers that you need to fill out according to the equation. You're going to have what happens one time, and then what keeps happening every day, every year, every hour. So I can already see here per hour means it happens every hour. So that's going to be my m. Now, the thing about the m is you have to check to see, is it making the temperature, or in this case, it's temperature. Is it making the temperature go up, or is it making the temperature go down? Or is it making, sorry, it's not even temperature, it's snow. The amount of snow on the ground, is it making it go up, or is it making it go down? In this case, because of this word melts, right, it's making it go down, which means because it's making it go down, it must be negative. Okay, so this is our equation, and then the number that happens one time is going to be 18, because that is my start. I start with 18 inches of snow on the ground, and then it starts to melt. So I start with 18, then it starts to melt. Now, this is 8th grade math, meaning that it's not in function notation. It's not how they want us to do it in 9th grade. So all I got to do is write this in 9th grade. It says write an equation for S. So I have to use capital S, which is equal to, in terms of t. So this is negative 1.5 t plus 18. Now, in 9th grade, this is what you're going to see. S as a function of t is going to be negative 1.5 t plus 18. However, in Delta Math, it's not saying write a function, it's saying write a equation. So again, that's the difference between those two words. Function looks like this. Equation looks like S equals. So you do need to know both depending on what the question is asking you. So negative 1.5t plus 18. All right, I'm going to do another one of these because this is a very important one to know. So I'm just actually going to do another one. All right, a baby is born. So again, there are two numbers you're looking for. My start and what's happening every something, okay? So baby is born, he begins to gain, okay? The word is gain, that means increase, right? He's gaining weight at a rate of 1.5 pounds per month. So there's the word per month. The weight of the baby at birth, okay? At birth is 5 pounds, that's my start. Write an equation, okay? That means just whatever they want, not parentheses, of W in terms of T. All right, so again, you start off with your 8th grade equation that you know, y equals mx plus b. All right, m is the thing that keeps happening. B is the thing that happens once. Because it says at birth I was 5 pounds, that's what I start with. I'm at 5 pounds. And then I increase because I'm gaining. So is that making this go up or down? Up, which means it's positive, 1.25 every month. So again, this is 8th grade. they want you to use, instead of a Y, they want you to use capital W, so make sure it's capital. And then this is not 1.25. Instead of X, they want you to use T, so you're going to put T plus 5. However, in 9th grade, you will see the word function. If you see the word function, you know they want capital W in respect to little t. All right, which is equal to 1.25t plus 5. So again, I'm just giving you the different representations. If they ask for an equation, all right, equation equal, all right, you're going to look at w equals 1.25t plus 5. If they ask for a function has the parenthesis part, f of x, g of x, w of t. Okay, the letters don't matter, you just need the parentheses. I think you should be good with the 2 examples. All right, we're going to do interpret a linear equation in context multiple choice. So these are the things that you're interpreting. So there are 4 kinds of problems. What I'm going to do is I'm going to make sure I go over each one. So I'm going to start off with slope. All right, so again, starting off at the equation, we're looking at y equals mx plus b, where m is equal to the slope. Like I said in a previous question, m is the thing that keeps happening, the thing that keeps happening per hour, per minute, per day, per something. If I'm given an equation, I automatically know what is attached to the variable is the slope. Okay, so you have y equals mx plus b. What is attached with the variable is the slope. And it doesn't have to be in this order. They could put it at the back. Just look for the one that's attached to the variable. All right, so at the beginning, so now that I know 3.75 is the slope, I just need to know in context of the problem what's going on. At the beginning of spring, Kai planted a small sunflower in his backyard. The sunflower's height in inches, h, after w weeks is given by this equation. What could the number 3.75 represent in this equation? So again, W is the time that's passing, H is the height of the sunflower. So remember, slope is what keeps happening to the sunflower. So it starts off with 11, but every week, right, it goes up by 3.75 inches. That's what I'm looking for. So you determine what it means before you look at the answer choices, then you go find it. So again, let me say it again. 3.75 is what keeps happening to my start. So 3.75 to my start is I'm adding 3.75 every week. So that's what I'm looking for. The sunflower's height after 1 week. No, they didn't tell me that it was 1 week, so that's not it. The sunflower's height after 0 weeks. That's my start, right? So that's my y-intercept. So that's not it either. The rate of change, and that could be it because that's what slope is. The rate of change on the sunflower's height. Yes, how is the sunflower's height changing every week? So yes, the sunflower's final height. Again, this is the slope. How it's changing every week. It's going up by 3.75 every week. It is not the final height. So there's only one answer there. So that's going to be C. I'm going to do another one of that example there because again, all they're going to do is just change the scenario. All right, so I'll do one more. All right, so we're going to interpret slope. Again, Jose is ordering a taxi from an online taxi service. He has to pay a flat fee just to order the taxi, and then he pays per mile. So there are 2 numbers again, one that happens once and one that happens every something. So in this case, it looks like it's per mile, depending on how far he travels. He wrote an equation to represent his total cost. Boom. And here's a prime example. So sometimes it's not mx plus b. They change the order. You just need to know that the m, all right, is always next to the variable. So find the variable. There's the variable right there. So 1.1 is m, which is the slope. 3.5 is the y-intercept, which is where I start. All right, so where y represents the total cost in dollars and x represents the number of miles he travels. What could the number 1.1 represent in the equation? So again, where is 1.1? Right next to the x. So that is my slope. All right, so this is my slope. That's the number that keeps happening. Okay, it doesn't happen one time, it just over and over again. So now that I know that, before I even look at my answer choices, I'm going to decide what it means and then match it. So I know that x represents the number of miles I travel. So every 1.1 mile every 1 mile I travel, I pay $1.10. I start by paying the taxi $3.50, and then every mile I'm paying 1.1. So every mile 1.1, another mile 1.1, another mile 1.1. So the The thing that keeps changing or happening over and over is my slope, which is 1.1. So again, what does that number represent? The total charge for 1 mile? Absolutely not. It is not the total that I am paying for 1 mile. It is the amount I pay every mile. All right. How far Jose can ride for $1? Absolutely not. This is again saying it's going to be $1.10 every mile Jose goes in this taxi. The change in total cost for every 1 additional mile. That's it. Every mile I go, it's going to change my total by $1.10. I'm just going to make sure on the last one. The initial charge, nope, because the initial charge is the y-intercept, which is $3.50. Okay, so again, that's how you interpret slope. All right, there are 4 types of questions. So we've covered interpret slope. I'm now going to cover interpret the y-intercept. So again, the y-intercept is the plus b, the number that happens 1 time. So once again, we're going to start on our question. Aaron is driving on a long road trip. He wrote an equation to represent how many gallons of gas he has left in his tank, G, which is equal to 14 minus 0.5 H, where G represents the number of gallons left in his tank, and H represents the time of hours. So again, you're driving on the road, H hours pass, and then I have G gallons left in my tank. So what could the number 14 represent? So I come and look over here. 14 is my y-intercept, okay? What is my y-intercept? Y-intercept is where I start. What I first start, my initial, what's happening in the situation before anything even happens. So what's happening in this situation is gallons of gas. So what gallons of gas did I start with? 14. 14 is the gallons that I started with. Then every hour that passes, I lose, and I know I lose because it says minus 0.5 gallons. But I start with 14. That's what I'm looking for here. Okay, my y-intercept is what I start with. How long it takes, how long is time? It's not even gallons, so heck no. How quickly the car uses gas in gallons per hour. I'm not asking how fast it happens. I'm asking what did I start with? So nope. The number of gallons of gas at time H equals 0. Yes, because at my y-intercept, X is always equal to 0, and X in this case is the letter H. But I'm just going to make sure on my last one. The number of gallons in the tank when the trip ends. No, because I don't care what I end up with. I care with what I started with. All right, so the y-intercept is what I start. Again, I'm going to do another question just in case you need it. So interpret the y-intercept again. An elevator travels down from the top floor of the skyscraper. So it starts up here, then it goes down. So wherever it starts, that's what I'm looking for. Its height in feet is given by this equation. So height is this. So again, this is my slope. It makes sense that it's negative because what does this mean? It's going down. Every t, which is time in seconds, every second it goes down 25 what in height? Feet. It goes down 25 in heat. I don't care about my slope, so I'm looking at just my y-intercept. What does that mean? That is the height that I start off at. I start at 500 feet high, then every second I go down 25, 25, 25, 25. But I start at 500, and that's what I'm looking at. I start at 500 feet tall or high. How long it takes, again, how long? No, I don't care about the time. I start at how high I start. The height the elevator starts at. Perfect. That's exactly what I said. All right, let's look at everything else. The elevator's final height. No, because that's the final height. I want the starting height. How quickly the elevator descends. No, I don't care the rate that it's happening at. I just care what I start with, which is 500. All right, so that's how you do the y-intercept. Moving on to the next kind of question you may get is interpret the y value given an x value. So again, Lauren is preheating, and these questions are going to change, but the concept is the same. Lauren is preheating her oven before using it to bake. Lauren wants to predict the final temperature after x minutes. Okay, so she's baking. She wants to say, what is the temperature after this time has passed? She wrote the equation, boom, where y represents the final temperature. So they even tell you what it is. All right, so y is the final temperature, and then x is the time in minutes. That's all you need, okay? What is the meaning of the y value when x is 1? So x is time. So 1 minute, after 1 minute, the temperature is blah, blah, blah. That's what I'm looking for. Now, you could go in as far as putting it in and seeing what it is, but no, I don't think that's even what the question is. But I do want to show you so that maybe you can see it mathematically. So here's my question. I'm going to make it a table so we can visualize it. And the question is, what's happening after 1 minute? So here's 1 minute. After 1 minute, the temperature is 96. That's how you're used to seeing it. I don't have to give you both numbers. I can give you one. You just have to know what it means. So when 1 minute has passed, the question is, what is the temperature? If that was the question, you would tell me it's 96 degrees Fahrenheit. But that's not the question. They're just saying, what does it mean? So this means 1 minute has passed, and then the temperature is blah, blah, blah. So the oven temperature after 0 minutes. No, we just said after 1 minute. So that doesn't make sense. The change in degrees in Fahrenheit for every change of 1 minute. No, we are saying after 1 minute. So not the change in, because that will be slow. The time when the oven's temperature is 0. Nobody even asked that. Again, when the time is 1 minute, what's happening to the temperature? The oven's temperature after what? Boom, right there. So that's what I'm trying to tell you. If you look at the question, decide what it is, then look at the answer choices. You do a better job than going right to the answer choices. Again, I'll do another one of those to just make sure that you got it. So interpret the y value given the x value. And if it makes more sense by you typing it in and then saying after 1 minute, the temperature is 96, that's fine. Do that. So London is taking a multiple choice test. Her grade is given by this equation where y represents her final score. Okay, so y is my final score and x represents the number of questions she got wrong. So however many questions I got wrong, this is my final score. What is the meaning of the y value when x is equal to 1? So again, what is x? The number of questions I got wrong. So again, put that in a sentence. When x is equal to 1. So she got what? 1 question wrong. So this is London. When London gets 1 question wrong, what is my score? Because y means what's my score. So again, you can put that in here and actually have a number if it makes it easier for you to say it. But you don't need to, because all this is asking is what does it mean, not what is it. If it was asking what is it when x is equal to 1, if she misses 1 question, she has a 98 on the test. That's what that means. However, on this, I only get 1. So I say if she gets 1 question wrong, she will have a certain score on the test. That's what I'm looking for here. The points she loses on every question she gets wrong. Nobody said anything about earning, losing, nothing. I said, again, she's going to get 1 question wrong, and then she's going to get this certain grade. Her score with 0. Did anybody ask with 0? Nobody. Again, x is 1 question wrong. So this is not something you should be choosing. The number of problems, who said anything about the number of questions on this test? Again, she's going to get 1 question wrong, and then she's going to get a certain score. The score she would get if she only missed 1 question. The only thing that makes sense on this thing. All right, so you're going to hit submit. And that's how you do that one. The last kind of question you're going to get, again, is just interpreting what it means. Is now you're going to do the x value for a given y value. And of course, they're going to mix it in. You're not going to know what order they're giving you. So there's roughly a linear relationship between the length of someone's femur. What in the world? I don't even know. Oh, it tells us the long leg bone in your thigh. Oh, okay. This ain't bio, but okay. And the expected height. Okay, so there's the length of someone's femur. I don't even know if that's how you say it. And the expected height. Within a certain population, this relationship can be given by this formula where h represents their height and f represents the length of femur in centimeters. What is the meaning of the f value when h is 130? You just got to know what h is. H is the height. So this is saying the height is equal to what? 130. What is the femur? I guess, I don't know, the leg bone in your thigh when the height is equal to 130. That's the question. So you're only looking for, if my height is 130, what is the femur? And again, I can put that in here, but you don't have to because it's just asking what it means. If it did say evaluate for when h is 130, you put the equation in, and then you go to when h is 1. Actually, let me do that one because it's not 1. So let me actually just type that one in so that I make sure that you know how to do that. 2.49 f. Now, it's not going to like f, so I'm going to put x plus 58.3. I'm going to make it a table so we know exactly what happens. All right, so I have my x, which is f, right? And how do I know that my x is f? Because I'm looking at this formula, mx. So the one that's attached to the variable, and that's x. So this one is attached to the variable. This is x. This is slope. This is y-intercept. All right, so now that I know that, I'm going to come right here. So I know my f is my x. So they're asking, what is my x when my y, which is my answer, is 130? So I'm looking over here and I'm looking for 130. I don't see it. Actually, I'm going to do it because if you don't see your value, press enter, 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 enter until you see, oops, not that, until you see 130. Now, a faster way of doing this, because I don't even know, I'm pressing enter really quick. Oh, there it is. Okay, so I don't even know if this is 130.51. So I'm just going to write it. What is equal to 130? What do I want 130 to be? Y. So Y equals 130. So sometimes when it's decimals, you will need to do it this way. I'm going to press home. And then I'm looking for a straight line. There it is. Where that straight line hits the graph. That's going to give me the exact number. So this number right here. So at 130, not 130.51, but at 130, it's 28.79. And I'm actually glad I did that. So with the Y values, because you're kind of just guessing, you can write, I want Y to equal 130. Then go look at where it crosses, and you can tell me what the X value is. All right, but back to what it means. Okay, so when X is 28.79518, right? My Y value, which is my H, is 130. That's what it means. So again, F represents the length of femur. So my length in femur is 29, but again, nobody cares because they're not asking. All right, when my height is 130. So if I'm 130 inches tall, centimeters, sorry. If I'm 130 centimeters tall, then my femur, the long leg bone in your thigh, is about 29 centimeters long. That's what it means. So when my height is 130, my femur is something. That's what I'm looking for. When my height is 130, how tall I am is 130, my femur is blah, blah, blah. All right, the femur height, the femur length for someone with the expected height of boom, it's my first one. My height is 130, my femur is something. All right, let's just double check everything else. The femur length for someone with the expected height of 28, no, my expected height is 130, but what is 28.8? My femur, right? So my height is 130, but my femur length is 28. But this says height is 28, which is wrong. Height is 130. The change, not the change. The change is again the slope, which is 2.49. The expected height for someone with a femur length of 130. Again, what is this 130? The height, not the femur, the height. And then this is the femur length. Nowhere in the question did it say the femur height. Okay, so again, decide what the answer is, then look at your answer choices. All right, I'm gonna do one more of that one just to make sure you're okay. There's roughly a linear relationship between the number of times a species of cricket would chirp in 1 minute and the temperature outside. For a certain type of cricket, this relationship can be expressed using this formula where T represents the temperature in degrees Fahrenheit and C represents the number of times it chirps in 1 minute. All right, so C, number of times it chirps in 1 minute. T, temperature. All right, I am going to evaluate it because, they might ask you to do this. So again, to evaluate, you type in the equation. And instead of C, I'm going to use X because you know how Desmos is at this point. Make it a table so we can see what it is. And I'm looking for temperature. So again, C is my X. So my X is not temperature. This is my temperature. I'm looking for my temperature to be 81. So again, we can press enter, 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 enter until we get to 81. This is going to take me forever. So a faster way of doing that is coming to tell the calculator, hey, I want my Y value to be 81. That temperature, my Y value. Then going home and then going to see where there's that line. And I just need to see where it crosses. Click on it. So there it is. 64.5163 minutes or chirps. The number of times it chirps. Okay, chirps in 1 minute. The temperature is 81 and the chirps, the number of chirps per minute is something else. But all I'm looking for is the temperature must be equal to 81 and then the chirps in 1 minute has to be something else. So the expected temperature in degrees in Fahrenheit has to be 81 according to this. If the cricket has chirped 0 times, nobody asked how many times you have chirped. Okay, so again, all I care about is the temperature is 81. The change in temperature in degrees Fahrenheit for each additional cricket chirp in 1 minute. Again, the change in temperature, how it's changing each time is going to be your slope. Okay, so that's not it. The number of times the cricket could be expected to chirp in 1 minute if it's 81 degrees Fahrenheit. Again, so that's the temperature in Fahrenheit is 81 degrees. What is the X value, which is the chirps in 1 minute, going to be, which again, if that was a question, 164.51613. And because this is real life, how many, you can't have 0.5 of a chirp, so that would have been 164 chirps. Okay, but that's not the question, it's just asking you to see this one. What's the last one? The expected temperature in degrees Fahrenheit if the cricket has chirped 81. Again, nobody cares how many times it's chirping, just that the temperature is 81. Okay, so I hope that has really cleared it up. If not, you can definitely come and see me. Those are all the 4 types of questions that you can get in order to interpret something. So we're going to move on to the next one, which is write and interpret functions. Okay, so now we're not even saying any of that. We're including different things. So it says Zachary is driving along a highway at a speed of 50 miles per hour. So again, given my equation, y is equal to mx plus b, where does the 50 go? Per hour. So that's my slope. That's the thing that keeps changing. You know, every hour, his speed is 50 miles. Every hour. Answer the question below regarding the relationship between distance and time. So I'm actually going to go ahead and put that in here so that I'm ready. So I already know that all I have is his speed every hour. They don't tell me where he starts. So that's okay, because that means he starts at 0. So his speed every hour is 50. All right, the independent variable, okay, independent, the one that doesn't depend on anything else is always going to be your x. Oh, it even says it. Never mind. All right, so independent variable x represents, okay, so what is x? All right, so again, 50 miles per hour. And what's the other thing? So that's, you're driving along the highway, that's your speed. Answer question between distance and time. All right, so x is always what? Time. And so distance must be y. So x is going to be time. So it represents the time, the number of hours driving, because it's definitely not going to be miles because x is always time. And the dependent one, and that means, again, what does this depend on? In other words, let me tell you what that means. I'm going to copy and paste this out real quick. All right, so dependent, and I'm going to write y equals, just so that you're completely aware. When I change the x value, right, so 1, 2, 3, 4, what's happening to the y value? It's changing according to whatever I change the x value to. So the dependent one is the one that depends on something else. So x is always the independent and y is always the dependent. So the dependent variable is not hours because the y is miles, because the miles depends on the hours. In other words, if I drive for 3 hours, I've driven 150 miles. If I drive for 5 hours, I've driven 250 miles. If I drive for 10 hours, I've driven for 500. This number depends on how much time I've been driving for. Okay. All right. So the function relating to this variables is, and I already have it written here, 50. And can I use x? Yes, because it says in terms of x. Write the function in capital R in terms of x. So 50x. All right, so R of 5. So again, I can come in here and type 5, but we are going to shortcut this, hit table, and we're going to go to 5. You can press enter, 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 or type in 5. So it's 250. All right, so what does this mean? Again, this is the time, this is the miles. So meaning after 5 what? Hours driving, Zachary has traveled how far? 250 what? Miles. Okay, so as long as you're keeping x with x and y with y, you are absolutely fine. So I'm going to do another question just to make sure you're okay. The keywords that I need you to know is independent. Independent does not depend on anybody else, is always x. Dependent depends on x, which means it's the y value. So independent is x, dependent is y. Keep that in your memory. All right, now that we know that, we just need to know the situation so we can know what's x and what is y. Rahul is driving along the highway. I feel like I just did this, so let me do a different one. This is driving on the highway. Here you go. All right, Jin has 12 gallons of gas in his car at the beginning of the trip. All right, so gallons of car. And of course, as I drive, every hour he drives, he's using 2.75, so his gas is going down. How do I represent that here? So again, remember you have y equals mx plus b, where m is how it's changing and b is where I start. So what do I start with? I start with 12 gallons in my gas tank. What's happening to my gas as I drive? It's going down, so my slope is going to be negative. How much is it going down by? 2.75. Okay, so there's my equation or my function. All right, answer the questions below regarding the relationship between gas remaining in the tank. Okay, so you just need to know this is the gas remaining in the tank, and this is the time in what? Hours. Okay, now that I know that, x is time. That's independent. X is always independent. So I can come here and say x is time, number of hours. Dependent is not going to be time. It's going to be the other thing, which is how much gas is left. Gas is left. Because, okay, so the dependent variable is gas because the gallons of gas remaining, so y depends on the number of hours. Meaning, I'm going to come in here and x is what again? Hours. So when I have 1 hour passing, I have 9.25 gallons left in the tank. If I have 2 hours passing, I have 6.5 gallons left in the tank. If I have 3 hours passing, I have 3.7 gallons left in the tank. This number depends on what I put in here. So if I put in a 5, this number is going to be negative 1.75. So again, whatever I put here is independent. This is dependent. So X is independent and Y is dependent. All right, so I'm gonna put the X back in here so I can make it a table so we can see whatever questions it is that answering. Write a function using capital C in terms of X. So when I write my in terms of X, so C of X equals negative 2.75, and I'm using X because it says in terms of X plus 12. So that's my function. And then what does that mean? After 4 hours, so I'm gonna come here to 4 hours, that says 2, 3, 4, or you can just type in 4. What does this mean? There is 1 gallon of gas left. Okay, so when C of 4 is equal to 1, it means that after 4, so this is the X. What does that mean? So you come here, X means hours driven. So hours driving will result in Y. What is the Y? Gallons of gas remaining. Will result in 1 gallon of gas left in the tank. Okay, so you just kind of need to go through the problem, write the function, decide what is X, what is Y, what is independent, what is dependent, and then answer what is the meaning in context. Let's take a look at interpret linear function coefficients from an equation. All right, Jacob, there are several types of questions you can get. Interpret the y-intercept, the slope, or the x-intercept. I'll go ahead and start with the y-intercept. Jacob is a salesman who sells computers at an electronics store. He makes a base pay amount each day and then is paid a commission as a percentage of the total dollar amount the company makes from his sales that day. The equation is represented by that, which represents Jacob's total pay on the day on which he sells X dollars worth of computers. So X means dollars worth of computers. What is the y-intercept of the equation, and what is the interpretation of in the context of the problem? All right, so once again, let me just remind you, we do have y equals mx plus b, where m is the slope and plus b is the y-intercept. So looking at your equation, this is the slope, the number that keeps happening, and then this is your y-intercept. So the y-intercept is 95. And remember, the slope is the number that keeps happening. The y-intercept is where you start your initial amount, what you begin with. So in this context of the problem, without even me looking, you want to first decide what it is. Okay, so he is selling computers and he earns a commission. So what this means is he sells this much dollars worth of computers, and then you multiply that number by 0.025. That's how much additional he makes to the initial amount of 95. So he gets 95 when he sells nothing. So that's what you're looking for. The base pay Jacob, that's it. The base pay Jacob makes regardless of computer sales. The percentage of commission that he makes on his daily sales, no. The number of computers he sold, nope. The commission Jacob makes after each computer sale, no. The total pay, the total pay that he makes would be P. Again, the y-intercept is the initial amount that he starts off with. So the base pay that he makes regardless of how many computers he sells. All right, we're going to do another question like that. I'll just do 2 of each just to make sure that it's very, very clear. All right, Maya needs to lease out a music studio to record her new album. The studio charges an initial studio fee. Okay, so again, the y-intercept is your initial. So they're telling you already that this 100 is the initial studio fee. And then plus an hourly fee. So this is the hourly fee. So it's $50 every 1 hour. So the number that keeps happening. So you're going to start off with 100, then you're going to pay $50 every single hour, and then this is going to be the total amount you pay depending on how many hours you stay. All right, so the total amount of money Maya would have to pay to use the studio for 2 hours can be determined using this equation. What is the y-intercept? So again, the y-intercept is just the plus b, the number without the variable. So that's going to be 100. And what does it mean? It's the amount she has to pay for the studio. So the total number of hours, no. The total number of hours that she would need to be there is T. The initial fee, yes. The total price of using, no, the total price would be P, because you're going to take the initial plus however many hours she's been there times 50. The additional price per hour of using the studio, no, the additional price is 50. So again, 100 is the initial, the start, what you begin with. So the initial fee of using the studio. All right, so we're going to take a look at how to interpret slope. So again, just looking at an equation, plus b is what I start with. Slope is the number that keeps happening, and then y is the total. Lily is in the business of manufacturing phones. She must pay a daily fixed cost. Okay, so the daily fixed cost is the y-intercept, which is 900, to rent the building and equipment. She also pays a cost per phone produced for materials and labor. So here's the phone, right? This is the cost that it charges for each phone for materials and labor. So if it's 1, she's going to pay 100 times 1 plus the 900 for the daily fixed cost to rent the building. And then this will be the total. All right, so this equation determines the total cost in dollars of producing P phones a given day. What is the slope of the equation, and what is the interpretation in the context? Okay, so again, this is the total she pays. This right here attached to the variable is what she pays for every single phone that's produced, and then 900 is what she starts off with just to rent the building. So our slope is going to be 100, and this is the cost that she pays per phone for materials and labor. All right, so the cost per phone for materials and labor, that's what you're looking for. The number of days to produce all the phones. No one talked about the number of days. The number of phones produced in a day. Nope. That's not what that means. P is the number of phones that she's producing per day. The additional that's what it is. The additional cost to produce each phone. So if I produce 1 phone, it's $100. If I produce 2 phones, it's another, it's $200 plus the rental. So it's the additional cost to produce each phone. The total cost to produce all the phones, nope, that's going to be C. The fixed cost to rent the equipment, that's going to be 900. That's what it's going to cost me. So it's the additional cost to rent or produce each phone. I'm going to do one more of slope. So once again, C is my total. This is my initial, what I start with, and this is the additional that I do. An electrician charges a set fee for every house call. Boom, set fee. That's my initial cost. Just to come out there, he's going to charge $100. And then charges an hourly rate depending on how long the job takes. So this is my $50 for every hour. So if he stays for 1 hour, he's going to charge $50 plus $100 just to come out. It stays for 2 hours, 2 times 50 is $100 plus the $100 to come out, which means this is the total. All right, so the cost of the electrician can be determined by this equation, where T is the number of hours the electrician spent on the house working. What is the slope of the equation? So again, slope is attached to the variable, so that's going to be 50, and that's the additional cost based on how long he's out there. The set fee, the set fee is $100. Just to come out, he's going to charge $100. The total cost, C is going to be the total cost because it includes the set fee plus every hour he's there, the fee that it's going to cost. The hourly rate charge, yes, so he's going to charge $50 every hour. The number of hours he spends at the house, again, no. T is the number of hours that he'll spend in the house. All right, last type of question for this title is interpret the x-intercept. Okay, so x-intercept is where it crosses the x-axis. So again, we don't have that based on this information because remember, this is the slope. This is the y-intercept. This is the total. We'd actually need to put that in decimals to see what the y-intercept is. So I'm just going to go ahead and type this out to be ready. So again, you can use what they use and then see what error it gives you and correct it as such. So I'll do that real quick. Oh, there's no error, so that's fine. We're going to zoom out or hit home, okay? And obviously, if I'm looking for the x-intercept, that's going to be where it crosses the x-axis. So it crosses the x-axis here. So what does that mean in the context of the problem? Skylar is going to drive from her house to city A without stopping. So she's going from one place to the other. An equation determines Skylar's distance from city A at t hours after leaving the house. This is what it is. So she's driving to a house. Her distance is getting smaller and smaller. And why is her distance getting smaller and smaller? Because she's getting closer to the house, which means your slope has to be negative because it's making your initial amount get smaller and smaller. What is the x-intercept of the equation? What is the interpretation? So the x-intercept is 4, and they don't tell me to write it as a coordinate, so I'm just going to write it as 4 and see what happens, which represents, okay, so let's zoom out. She starts over here, right? And she's driving. This is time, right? And then this is the distance from her house. So as she's driving, she's getting closer and closer to a house, getting closer and closer to a house. What happens right here? when distance is 0, she has arrived at her destination. So that's what the x-intercept means. It took her 4, is it hours? 4, yep, hours, okay? It took her 4 hours to get to her destination, which I guess is a home. She's driving from her house to, oh, she's going to city A. So it took her 4 hours to get to city A. That's what that means. The distance from Skylar's house to city A in miles. No, because again, if you're looking at the x-intercept, right, it's right here. This is not distance. This is time. So I should be looking for something that has to do with time, not distance. If it was asking for the y-intercept, then that would be something to do with distance. The number of gallons of gas. Who even mentioned gas in the problem? Nobody. The total cost to drive, the total cost is capital D. It's calculated by you putting in how many hours it took you to get in there. All right, the total time for the, yes, that's what I'm looking for. It took her 4 hours to get to city A. The average speed that she drives in miles per hour, it's got nothing to do with speed. It's not even talking about that. So the total time it took her in hours. All right, I'm going to do one more of this one. All right, and again, because it's the x-intercept, you do have to put it in. And I like that Desmos is just accepting exactly the problem. I don't even have to change it to an x. All right, so zoom out. I'm going to hit home real quick. All right, so I can see. Now let's read the situation. So we've got, that's the y-intercept. This is the x-intercept. At the end of the snowstorm, Michael saw that there was a lot of snow on his front lawn. The temperature increased and the snow begins to melt at a steady rate. Okay, so what's the y-intercept? The amount of snow on the lawn. What's happening as time is passing? So as I increase my time, what's happening? The snow is melting. So eventually at 10, all the snow is melted. And how do I know that? Because I can't have negative snow. Once I pass 10 over here, I can have negative. All right, so the depth of snow in lawn inches can be multiplied by the equation where t is the time in hours. So again, t is time after the snow stopped falling. What is the x-intercept? So the x-intercept is 10. And what does that represent? Something to do with 10 hours because it says t is time. All right, so something to do with 10 hours, the snow has completely melted, something like that. The rate at which the snow is melting per hour, no, that is the slope. It's melting at -2 inches. I think it's inches. I don't even know. Yep, inches per hour. The rate at which the snow was falling per hour, no, it's not even telling us anything about how it's falling. The original depth of snow, the original depth, remember that's my initial, so that's my 20. And then the number of hours until all the snow has melted. That's what I'm looking for. So again, if you're looking for the x-intercept and they tell you the x-intercept is time, you're looking for something with time. All right, perfect. All right, so now we're going to go to find domain graphically. So what is domain? Domain is going from the left-hand side all the way to the right. So I'm only looking at my highlighted piece of the graph, okay? So starting over here, is there a graph here? No, no graph, no graph. Graph starts exactly at -4. So now my question becomes, at -4, is there a hole? What I mean by that, so at -4, is there a hole? If there is a circle like this, you don't include it. But because it's shaded, you can look at it as there's a dot. There's a coordinate there. So because there's a coordinate, we're going to close it. All right, so just some quick notes. This means open. This means close. Okay, this and this mean open, and this with an equal sign, that with an equal sign means close. So that's the notation that you need. And I'll write it in both ways. So it starts at -4, boom. Where does it end? There's a graph there, 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 there's a graph there. Does it end at 10? No, because this arrow signifies that it keeps going on forever. And if I'm going on forever this way, what is that number? Infinity. So this goes on for infinity. Because infinity is an idea, it's not a number that actually exists. We cannot close it because it doesn't exist. So we're going to leave it open. So this is one notation, interval notation. The other notation that we're going to have is if we're in domain, we're looking at the x-axis. So this is the x-axis between the same numbers, -4 and infinity. And then again, looking at our notation, if I want it to be closed at -4, this is the notation I use. If I want it to be open, this is the notation I use. And the way it works is you say it's in between. So closed in between, open in between. X is greater or equal to -4, but less than infinity. That's what that means. So two separate notations on how to write domain. So it'll accept both notations. I'm going to use this one. It's not closed. So you kind of have to decide first. So this is that, and then it goes from -4 and then goes to infinity. I'll do one more problem just to make sure you're okay. That's a weird one, but I'll do it. All right. Again, because we're looking at domain, we're looking at the x-axis only, okay? So looking at the x-axis, where do I start on the left? So this one's a little bit weird because you can see there's a graph right here, right? But again, does it start right there? No, because this is an arrow saying that it keeps going this way. And if I keep going this way, it means that it's going towards what number? Negative infinity. So again, we are always going to write negative infinity, depending on what notation I'm going to write both of them. So negative infinity because it goes on forever. Do I include negative infinity? I do not. So if I'm doing that notation, I do it that way. If I'm doing this notation, I do it that way. And then I say x because it's domain. And then where does it stop? So I come from infinity. So all of here, there's a graph, there's a graph, there's a graph, there's a graph, there's a graph. Boom. At this point, after this point, there is no graph. So it stops right at that number, which is -8. So comma, -8, and then here, -8. All right. And then all I need to know is it open or closed? So if I look at that point right there, is there a circle representing open? No. So if there's no circle, then that means it is closed. I include the point, which means a closed bracket, or if you're doing it in this notation, less than or equal to. Now, since I put it in this notation the last time, I'll put the answer in this one this time. So we're going to go from... All right, we're going to go from negative infinity, open, so just less than on your keypad, and then x on your keypad, and then less than or equal to, because now I'm including the number 8. Okay, so it doesn't like this notation, which is interesting, but that's okay. So another way of saying this, or I'd put +8, y'all. That's what my mistake is, my bad. I meant to put -8, so that's my bad. So it's negative infinity less than or equal to x less than or equal to -8. I typoed it. I apologize. And this is a good point. Please make sure you double check before you hit submit that that's what you want to submit. So we're going to take a look at finding range graphically. So instead of left to right, we're going to now look at up and down. There are many problems that you can get. I'm not going to go over every single one of these. So I'll do a couple just to make sure you're okay. All right, so range. Range is from the bottom to the top. So now instead of looking at the x-axis, we are looking at the y-axis. So again, ignore every axis except the y-axis. So you're only looking at these numbers here. You do not care what's happening on the x, okay? So on these numbers, I start at the very bottom. Okay, is there a graph at the bottom? Yes, because this graph keeps going where? Forever. So does it even stop at -9? No, it keeps going down. So if it keeps going down, what is the bottom? Negative infinity. So this is the bottom, right? Forever in that direction. Then I'm going to start going up. And my question is, where do I stop? I don't, because if you look at this line, it's just going up forever. So that means that it's going towards what number? Infinity. And because it's not included, that is also open. Now, a few ways of writing this. So if you're writing it in the other notation, it would be the y-axis because it's the range. Because I don't include it, I could write it like this. Another way I could say this is that this is all real numbers. Basically, the graph exists everywhere you look. So all of those will be acceptable answers that you can put into here. So let's see. Boom, I could do that. All real numbers. All right, I'm just going to do one more just to make sure that you're okay. And again, it doesn't matter which one we do. It's just going from the bottom to the top. So looking just at the y-axis. So you're only looking at these numbers right here. Where is the bottom? So here's the bottom of the y-axis. If you notice on both of these sides of this graph, it has arrows which stipulates that they go on forever. So what is forever in this direction? Negative infinity. Okay, so then that's the bottom. Now we're going to go to the top. So we're going towards the top. I'm going towards the top. I'm going towards the top. Boom. After here, is there any more graph? No. So this is the top of the graph, which is at -5. Now the question being that, is that open or is it closed? Once again, unless you see a circle around it that's empty, it is closed. So this is closed. Because negative infinity is not really a number, it is open. Once again, because this is y, if you want to write it in the other notation, you would write it as such. All right, you keep the numbers exactly the same. This represents open, this represents closed, and you can write your answer in any one of those notations. So we're going to go use the y one because why not? Let's just practice that. So it was negative infinity. Use your keypad to do the less than, and then y, and then it's going to be less than or equal to negative 5. So again, whichever notation is comfortable for you, please go ahead and use that. And then if it's multiple choice and they give you different notations, you can actually recognize all of them. So that's how you find range. I'm going to do visual, range, and domain. The difference between this one and the ones that we've done before is that it has an actual start and a stop. In other words, you can see the holes or the circles that I was talking about. All right, so we're going to start off with both domain and range, and I'll do 2 questions of this just to make sure you're comfortable. So again, domain is which axis? The x-axis. I'm only looking at the x-axis. I start on the left of the x-axis. So again, no graph, no graph, no graph, graph. All right, now look at that point right there. Is it included? Yes, it is. So it's negative 11 and I include it. Because I'm talking about domain, other notation would be written this way. I include negative 11. Okay. Then I keep going. I go, there's a graph, 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 there's a graph. Where is there not a graph? There's no graph right there, right? So the graph stops right at 6. Okay, so this stops at 6. Now, do I include this or don't I? I don't, because this signifies that it's a hole at that graph. I don't include it, which means you use a parenthesis. If you're doing this notation, you just don't put the equal sign underneath. And again, you can put this in any notation that you want. It will accept both answers. The other thing we're going to look at both, is the range. So we have our range, which is from the bottom to the top of only your y numbers. So if I look at the bottom of the graph, nothing there, nothing there, nothing there. This is the bottom of the graph. So my range starts at negative 9. Because I'm talking about range, it's going to be y for that notation. At negative 9, do I see a hole? Do I see that circle? No. So that negative 9 is included. So that means it is closed in that notation, less than or equal to in that notation. All right, then I'm going to go up. There's a graph, there's a graph, there's a graph, there's a graph. So you see, I'm only looking at these y numbers. There's a graph, there's a graph, there's a graph, there's a graph, there's a graph. Even if you think this is the top of the graph, if you look on this side, there's a graph higher than that. There's a graph higher than that. There's a graph higher than that. There's a graph up to 10. So I go ahead and put 10 as my other number. And now, is this 10 open or closed since it's the top of the graph? It is open. That is signified by open parentheses or a less than without the equal sign. So both notations are fine. Then you just go answer the question. So I did both range and domain because I'm not sure what the question is. So it's domain. So for domain, I can put any one of these notations. Since I did this one, the last one, I'll go ahead and do this one. So closed, negative 11 to 6 open. So closed and open, and then it was negative 11 to positive 6. All right, I'll do one more. And again, I'm not going to choose the problem. It just depends. I did domain on the last one, so I'll put range here. However, all right, so we'll start off with domain. So domain is the x-axis, so I'm only looking at these numbers right now. So my domain 1 is my x-axis. All right, so starting on my x-axis on the left to right, is there a graph here? No, no graph, no graph, no graph. Graph starts right here. So this number it starts at is negative 2. Is that open or closed? Because there's a dot, that is closed. So this is negative 2, close bracket, or negative 2, because I'm looking at the x-axis, I put x, and closed is less than or equal to. All right, then the question is, where do I stop? There's a graph here, there's a graph, 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 stops right there at 6. So my next number is 6. Is that open or closed? So looking at that, that's a dot. It is closed. That is a closed bracket or less than or equal to. Again, either notation is fine when you put it in. All right, so now that we've done range, let's go ahead and do domain. So again, domain is now you're only looking at these numbers from the bottom to the top. So if I start at the bottom, is there a graph there? No. Graph, no. Graph, no. graph? Yes. So there's a graph starting at -9. So this is the range, starts at -9. Because I'm looking at the range, I'm going to use y. Do I include this? Yes, because this point and this point are closed. But even if one of them was open, if the other one is closed, then as long as there's one closed point, then you include it. So that means bracket less than or equal to with the equal sign underneath. And then you just keep going. Is there a graph? Is there a graph? Is there a graph? Graph, 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 graph. And we're right here. This is the very top of the graph. And so that number is 1. And whether you're looking here or looking here, they're both closed. But once again, even if this was open, this is closed, so you would still close it. So this is 1, 1. Closed is a bracket less than or equal to because it's closed. Both notations will work. So since I put in this notation the last time, I'll put in this notation now. So close, closed, -9, +1. Close, close, negative, close, closed, -9, +1. All right, so we're going to take a look at average rate of change. All right, so when you're looking at average rate of change, it's a fancy way of saying slope, but slope outside of linear functions. All right, so that is a formula that exists, that's slope. But because you don't know that it's the same as slope, there is another place that tells you that it's the same as slope. Average rate of change. Average rate of change is the change in the y value divided by the change in the x value for two distinct points on the graph. So if you look here, the change in the y value divided by the change in the x value for 2 points, x2 and x1, okay, for 2 coordinates. That's what it means. So this is the formula that we are using. We're going to go ahead and type that into Desmos. Now, to type that into Desmos, I'm going to say it again. Hit divide first, hit divide first, hit divide first, hit divide first. Then you're going to do parentheses minus parentheses over parentheses minus parentheses. Now, if you didn't hit divide first, this is what will happen. You go parentheses minus parentheses, and then you hit divide. This is the problem. It's only dividing the second thing. According to the formula, the division goes over the whole thing. So if that happens to you, just remember you do have to hit divide first so that it can go over the entire thing. Now that you know that, you just need to find your two coordinates. So you need the y's on the top, the x's on the bottom. The x's are always given to you in the question. So I'm going to go look at the question. Here's my x, and here is my first x. Here's my second x. So my first x and my second x. So it's just you put it in backwards. So I'm going to put x1 here, x2 here. All right, so it goes 9 and then 0. So I'm going to put my 9 and then 0. Once I put my x's in, now you just match it. So I don't even have to look back on it. I just need to match it. So I need to go to where x is 9. So here's my x-axis. Here's 9. I go to where x is 9, which is right there, and then I go left. So it's in between -10 and -20. So some of these graphs don't go like 1, 2, 3, 4. So you have to figure out what the spaces are. To do that, please look at the positive so you don't get confused with the negative. So it goes blank 10, blank 20. All right, so I'm going to try to go up by 5. 5, 10, 15, 20. That works. So that means when I'm going down this way between -10 and -20, it's going to be by 5. So -15. So 9 is -15. So 9 matches with -15 on the y. What does 0 match with? So I go to the x-axis, I go to 0. This is 0 on the x-axis. I go to the graph, which is right here. It's again in between, and that's going up by 5. So that's 5, 10. So that has to be 5. So 0 goes with 5. Once you get your answer, if it is not a whole number, you're going to click that fraction, and that's what you're going to put in. So it's -20 over 9. -20 divided by 9. Again, I'm going to do one more just to make sure you're okay. So you're going to start off with divide, hit divide, hit divide, hit divide, parentheses minus parentheses over parentheses minus parentheses. All right, according to the formula, you're putting the x's on the bottom. I always start with that before I even look at the question. I go x2, then x1. So here's x, x1, x2. So this is x2. So it goes 4, -6. So I'm going to come here. It goes 4, -6. Once I have that, I don't need the formula. I'm just matching. So I'm going to go to the x-axis and go to the number 4. So I go to the x-axis, the number 4 right here. I'm already hitting the graph. So what's the y value at that point? 0. When I go to -6, so I go to -6, which is right here. I go down to the graph, then I go this way. Again, it's in between, so you have to figure out what is the graph doing. So I go blank 4 blank 8. If I go up by 1, it doesn't work, because it doesn't go 1 4 5 8. That doesn't make any sense. So I'm going to go up by 2. 2 4 6 8 10. Okay, that works. So I'm going up by 2. So when I go back to my -6 and I go here between -8 and -12, it's going to be -8, -10, -12. So that's going to be -10. If it's a whole number, I'm good. I just put in the whole number. But if it's not, hit the fraction bar and put that in. All right, and that's how you do average rate of change. All right, we'll take a look at end behavior graphically. And end behavior is exactly what it sounds like. What is happening at the ends of the graph? Okay, what is happening at the ends of the graph? And before you even start answering the question, the first thing I want you to do is just notate what is happening at the end of the graph. So if I look at my graph on my left-hand side, here's my left. So X is going to be left and right, right? And then my Y is going to be what's actually happening. So here's the end of the graph on my left. This is my left side, right? What's happening there? Where's the graph going? To infinity. Okay. On my right side, what is happening to the graph? Where is that going? To negative infinity. Oops, why did I write -8? To negative infinity. All right, I actually have my answer. Okay. Now I just need to go find it in the multiple choice. Because it's multiple choice, the very first thing that you need to know is these are different. So you're looking for the ones that are different. They're going to give you two, the Y values are different. It's going to be a 50-50 chance. Then you just need to remember one. So you're just going to pick one. I'm going to pick this one. I know that on the left, it's going to infinity. That's what I'm looking for. And then Y's are different. So on my left side, X is going which way? To negative infinity. So X is going to negative infinity, Y is going to positive. That's the answer I'm looking for. X is going to negative infinity, Y is going to positive. X is going to negative infinity, Y is not going to positive. X is going to negative infinity, Y is not going to positive. X is going to negative infinity, Y is going to positive, and then I just double check the Y's are different. This is the answer. In this case, Y's are the same. So remember, they're not the same because one is going up and one is going down. All right, this one gets a little bit confusing for you for some reason. So I'm going to do a few. All right, this one I don't even need to do because what's happening on my left side? It's going down, and on my right side, it's going down. So they're both going down. Down to where? Negative infinity. So that's what I look for. So I don't even care whether it's my left or my right side. So I'm not even going to look at the X. Both of them, so the Y values, both of the Y's are going down. So this is up, positive, positive. This is positive, negative. That's up and down. That doesn't work. Down and down. That's what I'm looking for. This one is down and up. So if they're going in the same direction, I don't even care if it's the left side or the right side. They're both going to the down. So here's another example. What's happening at the end? So again, whether I'm on the left or the right, they're both going up. And what's up? Infinity. So I don't even need to really look. I'm looking for the one where it's going up. The Y is infinity, infinity. Here's my Y. And they could write Y or f of x. So I don't care if it's either left or right. They're both going up. This means down, up. So that's no. Up, up. That's what I'm looking for. This is down, down. This is up, down. Okay, so these ones are really easy. If they're going in the same direction, you don't care what X is doing. The one I think that you do need additional help with is if they're going in different directions. So I'll do one more of that and then that should be okay. All right, let's do this one. All right, so once again, let me go ahead and take a little snip. All right, so what's happening on the left side? So here's the left side. All right, what is happening on the left side at the end? It's going down. So down is to where? Negative infinity. So Y is going to negative infinity. So f of x is going to negative infinity. F of x is going to negative infinity. All right, but on the left side, and sometimes delta math they're going to trick you. It's not always starts. So this, I am going to make sure this does start on the left. So left is when x is going to negative infinity, right? When x is going to negative infinity. That's the left side. So this is negative infinity, negative infinity. This is positive infinity, so that's not the answer. And the other one's also got to be positive, so that's not the answer. So again, I'm going to negative infinity on my left. Okay, what am I doing on my right? On my right, I am going to positive infinity. So the other one I'm looking for is going to be positive infinity. So this one works. This one does not work because I'm going to negative infinity. All right, so all you really have to do is you're looking what's happening on the left. And you need to know that left is x is going to negative infinity. And then what's happening on the right? On the right is x is going to, and if you look at it, where is it going? To positive infinity. So when I say right, I mean x is going to positive infinity. When I say left, I mean x is going to negative infinity. And then you just look at where the arrow is pointed. If it's pointing down, it's going down to negative infinity. And if it's pointing up, it's going up to positive infinity. And then you match it. Just be careful because sometimes they switch this around. It doesn't always go left and then right. Sometimes they have right and then left. So just be careful. All right, so this one is A. All right, now we're going to do appropriate domain for real-world functions. All right, this problem seems very long, but it's really not. I'm going to go off the assumption that you know how to evaluate a function because that's going to save us some time in the explanation. So a company is manufacturing and selling shirts. The daily profit of the company depends how many shirts they sell. The profit in dollars of the company sells X shirts. So the x-axis is what's important. You need to know x-axis is shirts. All right, using the function that, find and interpret the given function values and determine the appropriate domain for the function. All right, so I'm going to put the function in there so I can evaluate it. So f of x. And again, you don't have to type this part. You can just start after the equal sign. So f of x minus 30. All right, big thing to know is that x is shirts and y is profit. So think about that for a second. If I'm thinking about shirts, can I have negative 10 shirts? No. Can I have positive 10 shirts? Yes. Can I have 0.5 of a shirt? No. Can I have 0.5 of a dollar? Yes. Can my profit be negative? Can I make negative $1 in terms of profit? Yes. So what that means is x has to start at 0 going to the right only in whole numbers because I can't have half of a shirt, right? So this is what my domain would be because that's my x. And then on my range, which is my y value, I can have negative numbers. So I can have negative and I can have decimals. So this one, I'm just going to write this as a note. I can have negative 5.2 and then I can go all the way up to $10.20. So this one, I can have negative infinity to positive infinity. But for domain, because I'm only talking about shirts, I can have 0, 1, 2, 3. Now we're going to prove that. All right, so remember, x is shirts. Okay, x is shirts. All right, so I have f of negative 9. So I'm going to make this a table, and I'm just going to type in negative 9. So negative 93. So this is saying, right? And again, this is just interpreting functions. This is saying if I make negative 9 shirts, I'm going to make negative $93 in profit. So if the company sells negative 9 shirts, they would make a profit of negative $93. This interpretation obviously does not make sense. Can I have negative 9 shirts? Absolutely not. All right, f of 2. So I'm just going to put in 2. Negative 16. So f of 2 is negative 16. What does this mean in the context? Shirts is 2, profit is negative $16. That does actually make sense. Meaning the company sells 2 shirts, all right, and they will profit negative $16. In other words, I'll make a loss, and that does make sense, right? If I'm a company, I don't have to make a profit. I could make a loss. All right, then we have 5.5. Can I have 5.5 shirts? Absolutely not. So this one is going to be I don't make sense, but let's find the answer. So if I make 5.5 shirts, I'll make a profit. This time I'm not even in the negative. I'll make a profit of $8.50, meaning if the company sells 5.5 shirts, which does not make sense, I will make a profit of $8.50. This interpretation does not make sense because I cannot make half of a shirt. Okay, so now that you know this, and I answered this question earlier. This helps you determine, what's going on with the domain. Okay, but I actually answered this question earlier. Domain is anything whole numbers starting, including 0, 1, 2, 3, 4, 5, going on forever. That's my domain. Then my range is negative infinity to positive infinity. So because this is a real world problem, we can't write, oh, I'm going to include domain, which means close bracket from 0 and then going to infinity. And I don't know where the infinity sign is. So I'll write INF. I'll write infinity. Open. I can't do that because this says that it includes every decimal in between 0 and infinity, which is not true. I only want whole numbers. So because of that, I can't write it this way. I have to write it a different way. So when you read this is how you write it. So can I have all real numbers? All real numbers means you can include decimals, negatives, everything you can think of. No, because domain, I only want 0, 1, 2, 3, 4. Now, if they were asking for the range, yes, that will be all real numbers. All right, then I go to non-negative real numbers. No, because I only want these positive, right? And again, I don't want anything real numbers because no decimals. All right, then I go to real numbers between 2 points. No, because I don't want anything to do with real numbers because that includes negatives. Integers. Integers is talking about, okay, see where it says positive integers, 1, 2, 3, 4, 5, 6, 7, 8. Integers also includes a negative side. So -1, -2, -3, -4. Since we already know we can't have any negatives there, it's not integers. Whole numbers. What are whole numbers? 0, 1, 2, 3, 4, 5. And you can see that's what I have written down. So that's the answer, but I just want to finish explaining these. Positive integers, only 1, 2, 3, 4, 5, 6, 7, 8, 9. And then integers between 2 points means that you start you start at 1, 2, 3, 4, 5, but there's a certain place that you stop. So you have a start and a stop. And actually, now that I'm saying this, let me see if there's a start and a stop for this because I did not check. Because this graph is going on forever, right? There is no stop. And there is no start because I can have, actually there is a start. Yeah, my start is 0. I'm tripping. I can't have negative, right? So I start at 0, but I go on forever because I can make as many shirts as I want to. All right, so that is whole numbers. All right, and I just realized that I made a mistake. I said it makes sense, but I clicked does not make sense. So just be careful what you are clicking. So I can make 2 shirts. I make 2 short shirts and make a loss of $16. That does make sense. I clicked not make sense by mistake. All right, so again, we're looking at domain and range in real world. You put in the equation, so 25,000 plus 4,000 x. I'm just going to make sure I copied that right, 25,000, 4,000 x. Okay, perfect. All right, so this is my equation. I'm going to evaluate it at a different spot to see if it makes sense or not. Before I even do this and you get lost in the math, I'm actually going to say what the domain and what the range is so that you have a good idea before we even start. As a matter of fact, I'm going to answer this question before we start, because by the time we do this math, you guys get lost at this part. All right, so domain-wise, all right, so here's the situation. A college has a financial aid formula that applies to applicants whose family income is below the threshold. The financial aid can be determined by the function. All right, so f of x is blah, 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 where x is the number of siblings. So let's stop right there. The x-axis is the number of siblings. So siblings is brothers and sisters and stepbrothers and stepsisters. Okay, so brother and sisters. So let's just start thinking about this real quick. Can I have negative brothers and sisters? No. So negative numbers are automatically out. Can I have 2.5 brothers? Absolutely not. So this again, and I can have 0 though, right? So this goes 0, 1, 2, not 1.2 because I can have 1.2 of a brother. 0, 1, 2, 3, 4, and so forth. And technically, if you're Nick Cannon, you can have it up to infinity, right? Infinity. All right, so that's, oh good, it types it in for me. So that's domain. Let's figure out what range is. So that was the x. All right, including half siblings and step siblings, that's fine. The applicant is living in the household. Find and interpret the given function and determine the appropriate function. Okay, so domain is the amount of financial aid that can be dispersed. So in terms of financial aid, right, can they give you negative money? No. So in this point, range is going to start at 0. Can I give you $10.50 in financial aid? Yes. So we're going to have decimals. Can I give you like 50,000? Yes, I can give you 50,000. So basically anything bigger than 0. So all real numbers bigger than 0. Now, because this graph is not going down, it's going up, it has no end. But if it did have an end, it would like hit the x-axis and it wouldn't be able to have negative money in this case, because they're not going to give you negative money. It goes on till infinity. All right, so this is all real numbers from 0 to infinity for range, and then for domain 0, 1, 2, 3, 4 up to infinity. All right, so now that I know my answer, actually even before I go ahead and click all of this, I'm going to come here. So this is only asking about domain. I did answer domain and range because your test might be range as well. All real numbers, no, because real numbers include decimals and negatives. Non-negative real numbers, no, because that includes decimals. Real numbers between 2 points, no. Even though I start at 0, again, I can't have decimals. Integers have negatives and positives, so that's going to be a no. Whole numbers, and again, this does look like whole numbers, so this is the answer again, whole numbers. Positive integers, and you'll notice positive integers start at 1, 2, 3, and doesn't include 0. So that's the difference between positive integers and whole numbers. Do I include 0? Integers between 2 points. I could write it as such. I could write 0 going to infinity, but it's just easier or less work for me to say it's just whole numbers. All right, now that we know that, let's actually just fill in the math and see why this doesn't make any sense. All right, so f of -4. So again, remember, -4 or the x means the number of brothers and sisters I have, including step and half. All right, so can I have -4? Absolutely. So I'm going to go ahead and say this does not make sense. Absolutely not. Okay, I can have -4. All right, I do need to evaluate what does that mean though. So add -4, hit table, -4, that's going to be $9,000. Oops, that's $900,000. $9,000, meaning a qualifying applicant with -4 siblings, which does not make sense. They would get $9,000, which does not make sense. All right, f of 3. So I come right here. If I have 3 siblings, I get $37,000. So 37,000. All right, does that make sense? Yes, that does make sense, because if I have 3 brothers and sisters, my household is going to get 37,000. Meaning a qualifying applicant with 3 siblings in their household will get 37,000. All right, 1.5. So if I have 1.5 brothers, okay, that does not make sense. Okay, so I'm going to go ahead and click does not make sense right now. All right, so that does not make sense. But if I could have 1.5 brothers and sisters, I would have 31,000 in my household income and financial aid. So, oh, I didn't even write it there. 31,000. All right, which means an applicant, this one is siblings, so this should be 1.5, would get 31,000. All right, and now that you know that, you know basically I can't have negative numbers and I can't have decimals, because both of those say don't make sense. So the only thing that makes sense is basically whole numbers including 0. And that's why they're doing that, so you can come here. But if you just think of the problem before you even start, you can get the answer and not get lost in the math. All right, write an explicit formula for a sequence. All right, any formula, I'm going to come right into the formula sheet and look for it. I'm looking for explicit. I don't know if it's arithmetic or geometric just yet, but because we haven't covered geometric, obviously it has to be arithmetic. So looking at the arithmetic, it says write the explicit formula. So I'm going to look right here. So let me go through definitions. The nth term is equal to, so the nth term is equal to a sub 1. A sub 1 is the first term. So what is the first number that you see? 24. So I'm going to type in 24. Then it says plus. So I'm going to type in plus. Then it says D. All right, so D is the common difference. To find the common difference, and I'm going to put this in parentheses because it's a little bit of math. The common difference is the second one, the second term, minus the first one. It has to be in that order. So the second one minus the first one. And I just want to go ahead and say this. If this first one was negative, then it would be minus negative 24. So just make sure that you don't drop a negative because it looks weird. Okay, it's always the second term minus the first term. All right, then we're going to go parentheses. And then n is the term, like it's the term number. So let me explain that real quick. So here n is 1. It is n, the first one. All right, it's not 24. Here, n is 2. It's the second term. N is 3. This is the third term. So the third term is 8, but n means what term number it is. Now, because it says find the nth term, it doesn't say find the fourth term. N is n. If it said find the fourth term, n would be 4. If it said find the 10th term, it would be 10. And then minus 1, parentheses. All right, technically you're done, but you might have to simplify this common difference, which would be negative 8. But let's see if it'll accept the answer without that simplification. I'm just a little bit curious. Okay, it does accept it. But, go ahead and simplify because it should be simplified, to be honest. All right, so you can see there that it does simplify to negative 8. So find the explicit formula is just literally just going through the formula and knowing the definition. So again, let's do one more. Explicit formula, you start with a sub n. The nth term is equal to the a sub nth term is equal to a sub 1, which means the first term. So what's the first number? I'm doing the wrong one, sorry. All right, what's the first number? 38. And we've only done arithmetic at this point. That's why I changed it to that. We'll talk about geometric the second semester. So the first term, which is 38, plus d. So I'm going to go plus. I'm going to put d in parentheses because to find the common difference, you have to take the second number, which is 44, minus the first number, which is 38. So common difference is the second number minus the first number. Then you keep going in the formula, open up a parentheses, then n minus 1. So n minus 1. N is not a number because it's saying find the nth term. N is just the term number. This is the first one. This is the second one. This is the third one. The next one will be the fourth, fifth, sixth, seventh, eighth, ninth, 10th. If they told you find the 10th term, you would come right here and say 10. Okay, but since they don't, you will say n. I am going to simplify it because I kind of think it should be simplified. Like maybe if you get multiple choice, this would not be an answer choice. So I'm going to replace this with 6 because 44 minus 38 is 6. All right, so that to me looks a little bit better and cleaner. So that's how you do explicit. Next, we're going to look at the nth term. Okay, so this is good because remember I was saying when you're given n, you have to put that number for n. All right, so again, it's the same situation. We're going to do what is the first term plus the common difference, n minus 1. So what is the first term? The first term is negative 16. And if you don't know what I'm talking about in this video, please go to just the previous title so you can see what all these definitions are in detail. All right, so my first term is negative 16. Then I have plus, so I'm going to go plus. The common difference, d, which again, the common difference is the second number, second term, minus the first term. So I'm going to go second term minus, and what is the first term? Negative 16. I don't drop the negative just because I have a minus. I write exactly what it says, the second one minus the first one. All right, and then here I have in parentheses n minus 1. Now the difference between this one and the last one is that it tells me you're not looking for the nth term, you're looking for the 97th term. So again, remember n means the number. So this is the term number 1, the term number 2, 3, 4, 5, 6, 7, 8, 9, 10, and it wants you to go all the way to 97. So n is just the term number. So it wants you to go to 97. Boom. You're going to take this whole line and put it in the calculator. So once you type it into the formula, you just put it in the calculator, and that's going to give you 1712. So 1712. So you're just evaluating it at a certain term. All right, I'm just going to do one more just to make sure. So again, all I'm doing is filling in the formula. So again, I start off with the first term. What's the first number? Negative 17. Then I go plus. So I'm going to hit plus. The common difference. So what is the common difference? How do I find d? The second number, which is negative 25, minus the first number, which is what? Negative 17. Again, don't drop anything. Just write it out. The second one minus the first one. Whatever it is, just write it. And then the last piece is n minus 1 in parentheses. So I'll just do that. N minus 1 in parentheses. And what is n equal to? It is the term number. So we are told the 51st term. So again, n is, this is the first one, this is the second one, this is the third, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is n, so the term number. So I want the 51st value. So tell me, what is the 51st value? Take that whole thing, Control C, put it right in the calculator, and it's going to give me negative 417. Negative 417. So we're going to take a look at write recursive formula for a sequence next. Again, the only one we've done is arithmetic, so that's all I'm going to cover. Looking at your formula sheet, the recursive one is this. So to find the a sub nth term, you need the a sub n minus 1, and all that means is the term before. So the one before plus the common difference. And remember, the common difference is the second minus the first. So you need the one before plus the common difference. All right, so let's go ahead and start off with the first term. So you have to define what is the first one. The first one is 6. Now to write out a general formula, it's just the one before, which they don't tell you, plus the common difference. And again, even just from the previous 2 videos or 2 delta maths, you know the common difference is the second number or the second term, which is 11, minus the first term, which is 6 in this case. Okay. And again, I do want you to simplify this. So you're going to take this whole thing and put it in the calculator so you can see what it simplifies to, but I think it'll just give it to you correct anyway. So the common difference is positive 5, so I will say plus 5. All right, so go ahead and do another one. So again, according to the formula, you're taking the one before plus the common difference. So this is the one before plus the common difference, which is the second number minus the first number. Okay. What is the first term? The first term is 19. This is just the formula. You're rewriting the formula based on your sequence. I'll do one more just to be sure. All right, so again, here's the formula. The one before plus the common difference. So the one before plus the common difference, which is the second number, 15, minus the first number, 11. All right, what is the first term? The first term is 11. All right, so now that we've done write recursive formula for a sequence, we're going to go explicit to recursive. So we're going to go from explicit, from it looking like this one, to it looking like this. So we're going to go from here to here. All right, so this one automatically looks like mx plus b. So there's really actually 3 things we're going to do. We're going to go from here to here to here, or vice versa, or in any order. All right, so if you're given a function, which means mx plus b, all you need to know is that, and I'm going to write this down, and you need to write it down, because if you don't have it at this point, you definitely need it. Common difference is the same as slope. To find the common difference, it's going to be the second term minus the first term. Okay, so again, the common difference is exactly the same as slope. So if you see the common difference, it is also slope. So when I have y equals mx plus b, with the slope being attached to the variable, if you look right here, the 2 is attached to the variable, so that's my slope, which is also my common difference. Okay, so now I'm writing what? I'm writing it in write it in recursive. So again, I come to, what does recursive look like? It looks like this, the term before plus the common difference. So the term before, oh, I'm clicking the wrong thing. So go ahead and write this, because I'm actually about to X out of that. All right, so the recursive is the one before plus the common difference, which is the same as slope, and that is my slope right there. So plus 2. What is my first term? Okay, so let's go ahead and put this into the calculator so there's absolutely no confusion at all. Just type it after the equal sign because it doesn't recognize this a sub n piece. All right, go ahead and make it the table. And okay, it's not making it a table. There's an error. It says try add in y equals. So let's go ahead and add that. Make it a table. And what is my first term? So it's not my negative second term because this is n, right? My first term is 9. All right, so we're going to do a few of these because it's going to go from different terms to different terms. But the key thing that you need to remember in this one is that slope is your common difference. Slope is your common difference. All right, looks like we have a similar one. Let me go ahead and change this question. Boom, that changed. That's different from the one we had before. Okay, so again, I'm going to type that into the calculator because that's going to tell me everything I need. -1 minus 4 parentheses and plus 1. Okay, make it a table, or I can't. There's an error. Try adding y equals. Let's go ahead and add y equals. All right, make that a table. All right, from that I can get my information. What is my first term? My first term is -9. And then they want me to write it in what? Recursive. So again, I go to the formula. What does recursive look like? The term before plus the common difference. So I go the term before plus the common difference. Okay, so I can't tell what the common difference here is because I don't have the slope. I don't have y equals mx plus b, right? But I can tell the common difference from here because remember, the common difference is the second term minus the first term. So I'm going to go the second one. I don't even need parentheses. The second term, which is what? -13 minus the first term, which is -9. So this is going to be -13 minus -9. That is the common difference. So I'm going to say that again. All right. I don't have the common difference to look at from here automatically, but since I typed this into Desmos and now I made it a table, I can see my first term is -9. My second term is -13. My third term is -17. My fourth term is -28. So to find the common difference, it's always your second term. So that's -13 minus your first term, which is -9. All right, I'm going to do another one just to make sure. And we're just going to see how they can present it. So that one is like the one we did before. That one is mx plus b. So I already know my common difference. But if it makes it easier for you, you don't even have to know that. You can type that into the calculator and hit table like we did before. So let's do this question. All right, so again, there's an error. Try adding y equals. Make it a table. And I can see my term. My first term is -5. My second term is -8. Now that I know that, if I'm writing my recursive formula, so again, in my recursive formula, I need the one before plus d. So the one before plus the common difference. So I'm going to come right here. If I didn't know the common difference is my slope, if I don't know that, I can still do it from here. My common difference is the second term, which is -8, minus my first term, which is what? -5. And you don't drop any of the negatives. And you can see that I still get the same -3. You knowing that the slope is the same as the common difference just makes it shorter. That's all it does. I still can do the question by typing it into Desmos and actually working it out. All right. What is my first term? My first term is -5. All right, so those are the kinds of questions you're going to get on that. So if you're being asked to write it in recursive, it could be given slope intercept form, then you have to go to recursive, or you could be given explicit form and then go into recursive. And that's all you do for that. Now we're going to do explicit. So you could be given this one or recursive, and now you have to make it into explicit. It's just going through the different forms. So this is 2 explicit. All right, so you're told that the first term is this, and this is the recursive. How do I know this is recursive? Because I see the previous term and then plus d, which this means this is what? The common difference. So the previous term plus the common difference. All right, write an explicit formula. So I'm going to go here. This is explicit. A sub n equals the first term. They tell me the first term is what? -3. So I'm going to type -3. Then next I should have plus, and then the common difference, which again, we would do the second minus the first. However, because you're given recursive, you're told what it is in the formula. So the common difference is the plus d right after the term before. So right after the term before, this is the common difference. So I'm going to put that here. And I'm going to take care of these signs in the calculator in just a second. And then parentheses n minus 1. Then parentheses n minus 1. Okay, it doesn't tell me find the nth term. We're just rewriting this. So this is what I need to have or write. I do need to take care of these signs, so I'm going to go ahead and talk to you about that. I'm going to see if it accepts that, but if it doesn't accept that, you just have to do the symbols. So what does a positive and a negative together mean? It means that it's a negative. The common difference is -10. So I'm just going to delete this and have -10. But I do want to see if it'll accept it as this. So give me a second. Okay, it does accept it. But again, it's cleaner. Okay, it's cleaner to write the -10 piece instead of plus -10. Okay, so it is a little bit cleaner to write it that way. All right, let's do another one. So again, this time we're going to explicit. So we're going from recursive to explicit. And all I need from the recursive piece is to know what is this common difference, so I can put it right here. Okay, so again, a sub n equals the first term. What's the first term? -1. All right, plus the common difference. And again, now instead of me saying plus the common difference, I'm just going to see what the common difference is. So the common difference is right there. How do I know that's a common difference? Because it's the previous term plus d. So the previous term minus 6. So minus 6 is the common difference. Then you have parentheses n minus 1. All right, so I'm just writing it in the cleaner version, but we just saw that Delta Math would accept both. I want to make sure I write in the cleaner version in case this is multiple choice. All right, I'll do one more just to make sure. All right, so again, a sub n equals the first term. What's the first term? It tells you the first term is 7. Then next is plus d. What's the common difference? From the recursive, you can see plus d is after the term before. So here's the term before. So the plus d is -9. And then after d, you have n minus 1 in parentheses. So after d, I have n minus 1. So all we're doing is going from one formula to the other. All right, now that we've gone between, we've written this formula down, we've written this formula down, we've jumped in between them. Now we're going to do add word problems. So if you're looking at a context problem, how do I know it's a sequence? Or how do I know that it's y equals mx plus b? All right, and that's the key thing. So with this one, you just have to be careful. If it says the first week, the first day, something like that, you know that it's a sequence. If it doesn't say anything, like the first is this, then it is a linear equation. So we're going to do a few just to make sure that you're okay. And again, because we haven't done geometric just yet, I'm going to choose the arithmetic ones. So I'll start off with arithmetic. All right, so here's my question. Ava is a teacher and takes home 46 papers to grade over the weekend. She can grade at a rate of 8 papers per hour. How many papers would Ava have remaining to grade after working for 5 hours? Did you hear me say first anything? The first paper, the first day, the first anything? No. Because you did not hear me say first anything, it is not a sequence. It is a linear function. So this is going to be y equals mx plus b. And that means I just need the number that happens one time and the number that keeps repeating, correct? So she's a teacher. She takes home 46 papers. What is she starting with? 46 papers, right? She's going home to grade 46 papers. So that's my plus B. I am grading 46 papers. As I grade, I'm grading 8 papers every 1 hour. So hour 1, 8 papers, hour 2, 8 papers, hour 3, 8 papers, hour 4, 8 papers. So that's my slope. Now, as I'm grading, does that make the paper, the total papers I have go up, or does it make it go down? All right, you should have said go down, obviously, because why would, if I grade a paper, how do I now have more papers? I've already graded. Okay, so going down, my slope is negative. So this is my linear function. Now the question is, how many papers would she have remaining to grade after working for 5 hours? All right, so I'm going to hit table. Now you just need to know the 5 hours. Is it X or is it Y? It is X. So I'm going to say 5 in here, and she'll have 6 papers. So again, 6 papers. So after 5 hours, I have 6 papers. All right, so we're going to do another question. All right, so Christopher opens a savings account at week 0. So you see, as soon as it says specifically what it is, you have to use what it says. So if it doesn't mention anything, it's linear. If it does mention, it's a sequence. So he opens a savings account at week 0. So this time you're telling me. So I'm going to put in a table and tell Desmos, hey, they said at week 0, okay, this person is going to make 1,800. 1,800. Pays no interest. He deposits another 90 each week after. So week 0, 1,800. Week 1, he's going to add, what is it? 90. So this is going to be 1,800 plus 90. It's going to be 1,890. Then on the third one, he's going to add what? Another 90. So that's going to be on number 2. It's going to be 1,980. All right. How much money does he have in his account after opening the account? Okay, so I have enough numbers. I only need 2 numbers. Because they told me week 0, I have to use what they say. If they don't say, then I'm going to just do y equals mx plus b into the calculator. If they do say, I'm going to put in the table of what they say, and then I'm going to make it a linear regression. And you can see that that linear regression is going to be 90x plus 1,800. I'm going to make that a table so that I can see the 42nd week. So I can't see the 42nd week right there, so I'm just going to type it in. 42nd week, I will have 5,580 in the account. 5,580 in the account. So 2 types of questions you're going to get. One is, it's a sequence. I tell you what to start with. The other is, I don't tell you what to start with. It's a linear equation. That's how you know the difference. I'm going to do a couple more questions just to make sure you're comfortable. Hakeem was given a large box of 54 chocolates for his birthday, day 0. Okay, as soon as they tell you what day it is, you know they're telling you the day. You got to put it in. So I'm going to go input a table, and I'm going to say on day 0, right, he had what? 54. So if they don't tell me on day 0 or day 1, it's going to be a linear function. So on day 0, he had 54. He eats exactly 3 chocolates every day. Okay, so 1. He eats 3 chocolates. How many are left? Well, if you don't know how to do the math, you go right here. You're going to subtract 3, because if he eats it, it doesn't increase, it decreases. So now it's 51. All right, I'm going to do one more. He's at 51. He's going to eat, right, 3 chocolates again. So he eats 3 chocolates. How many chocolates is he now at? 48, and so forth. You only need 2 numbers, to be honest, so you don't even need to do this one. All right, but I just wanted you to get the process. He's eating chocolates. That number is going down. Okay. So another question is, how many chocolates are remaining in 8 days? So right now, this is day 2, because that's the X value, day 2. To find out how many is remaining in 8 days, I could repeat this process more, but nobody has time for that. Click that. There's your linear regression right there. You're going to copy that, Control C, and put it on the next line, Control V. This is my linear regression. For me to see day 8 or day 50 or day 158, I'm going to press that, Settings, Table, so I can see day 8. So I'm going to say day 8. He's going to have 30 left. 30 chocolates left on day 8. Okay, so again, the key is this. There are 2 kinds of questions. You're given either a sequence question or a linear equation question. To know the difference between the 2 is, for a sequence question, it's going to tell you day 0, day 1, the first week. And it doesn't have to be an actual number. It could be in words. So you look for the first week, the first time he ran, the first something. If it doesn't specifically say, then it is a linear function. It's y equals mx plus b. Okay. We're just going to do a few more of like whatever you can get. All right. Someone is running. Brandon is running to train for a race in the first week. Again, so if they tell you the first, you have to use the first. All right, so if they're telling me a sequence, I'm going to put that in because it's nothing for me to really read. So they're telling me in the first week. So I'm going to say number 1. They didn't say in the 0 week, the first week. So 1. In his running plan, he will run 10 miles. So the first week, 10 miles. The plan calls for Brandon to increase his weekly mileage by 2.5. So the second week, he's going to increase 10 plus 2.5. So now he'll be at 12.5. And that's all I need. I only need two numbers. I was doing more before, but I'm just going to stick to two. So now I'm going to hit the function. So this is my function, and it's in decimals. We can make this into a fraction, but since it's not asking me what the function is, I'm not going to bother. I'm going to hit table, settings table, so I can see whatever the question. If Brandon sticks to the plan, how many miles would be expected during his 17th? So now I don't care about his first or his second. I want 17th, which is what? 50. If this question said write the function, I would write this, but I would go and make sure that I make 2.5 into a what? A fraction. So I'd hit 2.5, make it a fraction, and then come here and write 5 over 2. And then go to repeat the same process for 7.5. So 7.5, make that a fraction, 15 over 2. Okay. So if it asks me for a function, that will be my function. It could ask me write the recursive or write the explicit, but we've gone over how to write those as well. So in this one, it's just kind of making sure that you understand what is the difference between a linear and a sequence. I think I'm going to do one more because I've done so many sequences. Hopefully the next one is not a sequence. I did salaries, I think. I don't think I did a salary. All right, Jamar just got hired for a new job and he'll make $48,000 in his first year. Okay, again, because it says first year, this is also a sequence one. Also, they're mostly just sequences. All right, so again, if it's a sequence one, we're going to put it in so we can see what it is. My first year, number one, is going to be 48,000. All right, my second year, he can expect to get a raise of 3,500. So he starts off with 48,000. He gets a raise of 3,500. So his second year is going to be making 51,500. All right. How much money or salary will he make in his 18th year? I could keep adding until I get to 18, but nobody has time. You're going to click this button right here, copy your linear regression, and make it a table so that I can see when his 18th year is going to make. So his salary is 107,500. Okay, here's one question. It says the first year. So this is a sequence as well. I'm just trying to find one that's not a sequence at this point. Week 0, that's a sequence as well. I don't see anything about, I don't see anything about first or 0. Okay, so this is not a sequence. I just wanted to do one more of these because I did a lot of sequences. All right, so Karen is a teacher. She takes home 68 papers. So is 68 my slope, the thing that keeps happening, or is 68 what I start with, the thing that happens one time? It happens one time. She takes home 68 papers. So my function is going to be here is 68, my y-intercept. All right, she can grade at a rate of 6 papers per hour. That means every hour she's grading 6 papers. Hour 1, 6 papers. Hour 2, 6 papers. As she's grading these 6 papers, that's the number that keeps happening. What's happening to the total number of papers? Is it going up or going down? Well, as she's grading, she then has less to grade. So this one will be a -6. All right, so again, if you're not told first or 0 or anything in the problem, then it's a linear function. You just have to write the function. And then the process is the same. Hit settings, table, and you're looking, how many does she have after 7 hours? So we're going to come here, hit 7, and she has 26 papers left to grade. So hopefully that was really clear to you, the difference between sequence and linear function. All right, so we're going to take a look at find explicit sequence / function from the graph. And there are a few options that you could get for this question, and I'm going to make sure that I cover both. All right, so it says use the graph to fill and answer the sentence below and find the explicit formula. Okay, so I need my Desmos and I need my formula sheet. All right, explicit formula is going to be under sequence, explicit formula. So this is what it looks like. And then it says, finish the sentence below. Okay, the graph above can be best said to represent what? Okay, so let's go over a couple of definitions. If you see that it's just dots and not a line connecting, this is discrete. So discrete is just dots, it doesn't connect, because what this means is you can't have 1.5. You cannot have 2.2. Okay, it's discrete values that are there for every x. There's a discrete value for y. So this is discrete. If it's continuous, it is continuous, means that there's a line joining, which means you can have any kind of decimal, radical, anything you like. So an example in real world would be, say this was shirts. This is the number of shirts. I can have 1.5 shirts, so that's discrete. Okay, let's say that it was, what can I have decimals for? Let's say it's the height of something, or say, let's say it's time. I can have 1.5 hours, so that's going to be continuous. So that's just some real world examples of discrete and continuous. So this graph above is best said to be a sequence, because sequences are discrete, and because a sequence goes 1, 2, 3, 4, whereas a linear function is going to have a connected line, okay, depending on what the context is. All right, so since it's a sequence, let's go ahead and write the explicit formula. So again, the formula says the first term, and if you don't know what I'm talking about now here, please go back to the examples that I wrote down for write explicit formula for sequence. All right, so A1 is the first term. So what is the first term? When X is 1, Y is, I don't know. Okay, so let's find out what that is. So we're going to go into the calculator. We're going to put in what we do know. So what do I know? I know that 2 is 2, and I also know that 6 is -1. I'm going to make that a linear regression, and then I'm going to copy the y equals mx plus b part and make that a table so I can see exactly what the first term is. So make it a table, and now I can see my first term is 2.75. Okay, so if they don't give you the first term, I guess you got to go find it. So my first term is 2.75. So I'm going to say 2.75, and I don't know if they're okay with decimals or they want fractions. I'm not sure yet. Plus d, which is my common difference. All right, so plus d, my common difference is my second term minus my first term. So here's my second term minus my first term. So again, if you don't know what I'm talking about, please go back to the title that says write explicit formula for sequence. I go over that in detail. So my second term minus my first term, which is 2.75. My common difference is negative 0.75. Then I have parentheses n minus 1. Because they don't tell me to find my 15th term or my 20th term, I'm just going to leave n in the answer. Perfect. Okay, I do want to see what they do or how they do it, because I'm curious. Yeah, I'm not curious anymore. Not doing any of that. Okay, so I'm going to do another one just to make sure. So I'm going to do another sequence one. Again, remember, sequence ones are discrete values. In other words, the graph is not connected, so it is not continuous. So this is an arithmetic sequence, because that's the only sequence we've done so far. So there is no choice there. All right, to write the explicit form for it. So to write the, this time it doesn't say write the explicit. Oh, it does. Okay, so explicit. It looked like it was in function notation, but that's okay. All right, so write the explicit form. I need the first term, which means this time they gave it to me. The first term is -2. All right, then I need the common difference, which is the second term, and they did give me the second term. So this is going to be -1 minus -2. And you're free to put it into the calculator too if you want to just do it that way. That's fine. So second one minus the first one. So second minus the first. So my common difference is +1. And then I should have parentheses n minus 1. So parentheses n minus 1. This is an invisible one. I do not need to place that there, so I'm just going to delete it. But you can, and I think it should still give you the correct answer. In fact, I'm going to put it there just to make sure. But this is the explicit form for this discrete sequence. Perfect. All right, so let's do some examples of what's not discrete or linear functions. So you can see the discrete values are connected, meaning you can have the things in between them. So I can have -2.5 and it'll give me a value. All right, so if it is connected, it is continuous, and that is best said to be a linear function. And now I just need to write y equals mx plus b, and you should be pretty good at this point, but if not, it's okay. You're going to input 2 points. In this one, it doesn't matter what points you're inputting, so I'm just going to start on the far right, 2, -3, and then here I'm going to put -1, -5. I only need 2 points, but you know, why not? Let's go ahead and put everything, because there are some questions that don't go in order. As a matter of fact, I need all of them. Why am I lying? I need all of them. Put everything in there. Do not be lazy. Okay, every point they give you, Now let's make it a linear function. So there's my linear function. Oh my gosh, it's a repeating decimal. What do? I copy it. I put it right here. Okay, make it a fraction. Okay, that fraction looks so weird, guys. So what do? It's a repeating decimal. What's repeating? The 6666. The calculator got tired of writing it and wrote 7 to round it. But 6 is what's repeating. So I'm going to click it until it goes away. Then click it until it comes right. I'm lying. It's not coming back. Why are you not coming back? Let me do it again. 0.6. Unless I missed it. Oh, it's yeah. There it is. Okay. I think I missed it before. That's kind of interesting. I wanna see what happened before. So I think I typed in a 3 somewhere. There. Y'all, I typed in a 3. Please be careful, okay, because that's why it wasn't coming back. All right, boom. I took the 3 out and there it is. So this is 2/3, and then this one, another repeating decimal, put that in there, and then keep making it, make it a decimal. Make it a fraction. That looks really weird. Keep repeating, goes away, comes back, boom. Those are my 2 answers for right here. So I'm going to copy that, paste that, Control C, Control V. Where I see this piece, I'm going to put 2/3. And where I see this piece, I'm going to put 13/3. So this is my linear function that I'm going to Control C, Control V, and that worked. Just be careful. This already says y equals, so you don't need to say y equals, y equals. So boom. And submit. I'll do one more just to make sure we're okay. Let's do one that's going down this time. That's going up. There we go. That's going down. All right. So again, how do I know it's a linear function? Because it's continuous. It joins. Okay. So it's not discrete. So this is going to be a linear function. All right. What is the function for this linear function? You're going to put in all of the points, because I just realized that sometimes they skip. So because this is not changing by 1, like it doesn't go -5, -4, just make sure you just put everything. And make sure you double check to see what you were typing, because you see me making typos. Actually, I'm just really tired. All right, so hit linear regression, copy your answer. It's again a fraction. So I'm going to take this fraction piece right here. I want to know what it is. Hit fraction. It looks weird. Keep repeating it. It's going to disappear and it's going to come back. So this is 1/3. All right, this next part, take this one again, Control C, Control V. Again, make it a fraction. It's repeating. Keep taking it, making it repeat. It goes away until it comes right back. So this part right here is 16/3. Okay, now just double check that, because I really shouldn't have erased the original one. So again, copy this, paste this, and if it's right, then it's going to match. So zoom out. So purple and blue should be the same line. Yes, it is. And it goes through all the purple dots. Yes, it does. Okay. So this is your answer. And since I now know that it's going to copy and paste it, Control C, Control V, get rid of that y equals piece. And now I have my function. All right. So we're going to look at linear inequality systems graphically. All right, so can you graph these inequalities? Of course, the very first thing that you do is go ahead and type them in exactly as you see them. And if you don't want to use the keyboard, you can use this right here. Clearly, that is not exactly what I see. So again, the importance of going back and looking to make sure that you typed exactly what you see so that you can get the question right. So just double check it, make sure that it matches. Perfect. All right, so I just have to transfer my answer from here to here. Okay, so what you're going to do is you're going to zoom in until it's going up by ones. See how it's going up by 1? 1, 2, 3, 4. If I have actually, before I zoom in, I'm going to do one at a time. So I'm going to hide this one real quick and just do the green line. So I can see that it goes right here at 1, 0. So 1, 0 right here crosses the x-axis. All right. So it crosses the x-axis right there. So I'm going to click that. It also crosses the y-axis at -1. So this one's an easy one to copy because these are whole numbers. All right, on the next one, even if it is a whole number, I'm going to show you what to do if it's not perfect. Now I'm going to change the line. This is a dotted line, so I'm going to change the line to dotted. Which side is shaded? That's what I need to shade. All right, I'm going to zoom out and look to see, do this look like what I want? Yes, so you can see this little triangle right here. I can see that little triangle right there. So this is good. All right, my second line, so I'm going to hide this one and show that one. Let's see if it's some good points. Okay, these are some good points, but again, you're not going to get good points all the time. So I am going to show you with this one. So once again, you're going to zoom in until it's going up by 1. So you can see 5, 6, 7, 8. So that's going up by 1. All right, then you're going to look at the line. So you see me moving around to where I see the line. All right, you're going to look at the line, and what you're looking for is one box. So you see it goes 5, 6. This is one box. Before I even start that, I'm going to show you a little shortcut, and I'm not going to be able to show you this on a test, so make sure you remember. Click settings, and then you see where it says minor grid lines. Minor grid lines. You're going to uncheck that. It's going to make it easier for you to see your corners. So if you look right here, all right, is this line going through here, 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 or here? No, this is not a corner. This is not a corner. This is a corner. So I come here and I slowly move my mouse till I see it. 6, 5. So I come over here, I go to 6 on X and 5 on Y. Okay, it's not going to let me do that point because it's overlapping this one. If I click it, it's going to delete. So I need to find another one. So I'm going to keep moving. Is this a corner? No, it's not. Is this a corner? No, it's not. Is this a corner? Yes, it is. So I'm going to come right there. And again, that's 9, 4. So I'm going to go 9, 1, 2, 3, 4. That's a corner. All right, obviously, if I keep going this way, I'm going to be off the graph. So I really just need to go back on this side. And this is a corner. This is not a corner. This is a corner right here. So this is a corner as, this looks like 3, 5, 3, 6. All right, so 3, 6 is a corner. So 3 and then 6 is a corner. All right, so now that I have that line, I'm going to press home so you can really see it. Yes, it looks like it's going down. And does it go through 7? It does. So that's correct. I just need to make the line what kind of line? A dotted line. So we're going to come up here and change it to a dotted line. Then we need to shade the bottom side. So not the top side, but the bottom side. So we're going to change the shade to the bottom. So when I put the second one back up, I should have my overlap color is on the bottom. So you can see that my overlap color right here is the bottom. Now for me to kind of just make sure that it looks the same as mine, I kind of need to zoom in a little bit because this one only goes into 10. So does it look like this? Yeah. So the bottom part is mostly to the right. You see that? The bottom part is mostly to the right. So this looks like I copied it correctly. Once I'm sure I've copied it correctly, I need to pick a solution. So a solution is anything where they overlap, where the colors overlap, but stay away from dotted lines. That means any point on this dotted line is not a solution. This is not a solution. Any point on the dotted line is not a solution. So pick anything inside here. So I'm going to pick 6, 1, this point right here. I'm going to check it by putting it into the calculator. So you have 6, 1. If it goes into my overlap, I'm good. So 6, 1 does work. So I can use that as a point and submit it. Perfect. I'm going to do one more just in case. Let's do this one. So again, I'm going to copy everything in. All right, once you've copied it, please make sure that you double check to make sure you copied everything correctly. I've double checked, I'm good to go. So now all I have to do is just transfer what I see on my Desmos into my answer. All right, so once again, hit home. I'm going to put the minor grid lines back on because what happens if you forget, that's how you get rid of it. So again, when you see so many boxes, right, you click this spanner or the set it, I don't know what you call this, spanner, wrench in the States. And then you're going to click minor grid lines and that's going to make it just the boxes, okay? But I'm going to put it back in case you forget. I'm going to show you how to do that anyway. All right, so I have my 2 lines. I'm going to hide one. So I click the color, hide that. And again, I check my nice points. Okay, these has 2 nice points, but I really want to practice how to get them. So I zoom in till it goes up by 1. Okay, so it's going up by 1 right now. I'm going to go away from that nice point and start somewhere else. So I'm looking for the corner. So here is a nice point right here. It goes through right through a corner, and if it's a corner, you're going to get a coordinate. So this is 2, -1. So x is 2, y is -1. All right, then I'm going to keep going. I see another corner right here. That's 3 and -2, 3 and -2. So as long as you zoom into it, it's going up by 1, the corner should be easy to spot. So that's my line. I'm going to zoom out so I can see, does it kind of look like it? Yes, you can see this little triangle piece right here, this little triangle piece right here. All right, so I just need to make it dotted. So we're going to change the line to dotted. Which side do I need to shade? This side right here. So we're going to go, yep, that side right there. So now this is matching exactly. Once I get it matching exactly, we're going to hide that one and go to the second one. And again, we're going to check the nice points. Yes, it's a nice point. Ooh, but look at this nice point. It is off the graph because it goes past -10. So again, in this kind of situation, you will have to know how to do the corners. So I'm going to zoom in till it's going up by 1 again. See, 1, 2, 3, 4, 1, 2. All right, go to the graph, and I'm not going to use the nice point because I want to practice the corner. Is this the corner of a box? No, because remember, a box is this big one when it goes up by 1, 1. All right, this looks like a corner, so I'm going to come right there. And is it a corner? 2, and it should be like 2 and 8, but let's see if I can get it. You got to really be steady hands on this stuff. All right, that corner is not liking me. I'm going to go to another one. All right, this looks like a corner right here, and there we go, 4, 9. I really wonder, why is this not giving me 2, 8? Oh, there it is, 2, 8. Okay, so this is a corner. This is not a corner. This is a corner, 4, 9. So I got 2, 8, and 4, 9. Okay, I can go find a different corner if I want to. So again, is this a corner? No. Is this a corner? Yes. So anytime it's a corner, I just try and get the actual whole number. So if I did this right, it should be -2, 6, -2, 6. Yes, it's right on the line. So this is okay. I'm going to zoom out so we can see. Yeah, that looks like it's on the top part right here. There's no kind of triangle over here, this little piece. So this looks right. Solid line. And then where do I shade? The bottom, right? So I just need to shade the bottom. All right, I'm going to put both of them back in there. Click home. Zoom in a little bit. And look, my intersection should be at -4, 5. -4, 5. Yes, that's true. Okay, so I'm always double checking to make sure that I see where I'm supposed to be. So the final thing is, what is a solution? So again, anything is a solution. Stay away from what? This dotted line. Okay, so anything here is a solution. Stay away from any points that's right here. Now, my question to you is this a solution? No, because this line is solid, but this one is dotted. So I'm actually going to pick one of these points right here. So I'm saying -6, 4 is a solution, and that's what I'm checking, a point on the line. -6, 4. Because most of the times it's multiple choice, and they're asking you to see if you know. If I'm on a solid line, is that a solution? That's what they'll usually check. Yes. If this is both a solid and a dotted, is this a solution? No. This one right here, is that a solution? No, because it's on a dotted line. That's the stuff they'll check. Okay, so -6, 4 is on a solid line, so therefore that is a solution. All right, the next one we're going to take a look at is write a single inequality from context. All right, so how do I know that it's only, because they're not going to tell you it's a single inequality, right? How do I know if my inequality is 1 sentence or 2 sentences? What gives it away is the number of numbers. All right, so if you see less than 3 or less numbers, it's 1 sentence. If you see 3 or more numbers, it's 2 sentences. So that's how you're going to keep track of that. So as you're reading, you're going to highlight anywhere you see numbers. So as a matter of fact, I'm just going to kind of glance and I'm going to see there's a number right there. On the left of that number will be a keyword or defining what it is. So what's on the left of 123? It says at most. So that's my keyword. So I'm actually going to start off with that keyword, at most 123. So I have at most 123 people, and I need you to be writing it down so that you can truly see. At most, I have 123 people. At most, at most, at most. Can I have 124 people? You should have said no, because I said I have at most 123. at most. Okay, so can I have 123? Yes, because the most I can have is 123. Can I have 122? Yes, because again, at most I can have 123. So if you look at the direction that I'm going in, I'm going to the left. Now the question is, and you just look at the little arrowhead, that's what the inequality looks like. Do I include this 123 number that I started with? Yes, I do. If I do, I put the equal to or equal to underneath that. So this at most is less than or equal to. That's how you read the keywords. So this piece right here is very important. Make sure you write it down so you can see, especially with the language, to help you with the inequality. All right, so now I just need to find some other numbers, and I don't see any other numbers, so this must be a single inequality because it must be my two numbers are hidden. So the drama club is selling tickets to the play to raise money for show expenses. They're selling both adult tickets and student tickets. So the thing they're doing is student, adult, and student tickets. That's what they're doing. All right, so that makes up all the people who are going to be in the auditorium. Write an inequality that could represent the possible values for the number, and look at it. Number of students sold, and they're telling you use S for student, and the number of adult the number of adult tickets sold, use A. So A is adult, S is students. That would satisfy this constraint. So what are they saying? There's an auditorium. It can hold at most 123 people, or 122, or 121, or 120, or any kind of possibility underneath. These are people. What kind of people are there? They are students, which says it's S, and then there are adults. And together, so S plus A has to be at most 123 people. And that's how you write a single constraint. So S plus A is less than or equal to 123 people. All right, we're going to do another one just to kind of make sure that you're okay. I'm just going to make sure that the number is something else. So yes, this number is something else. So perfect. Let's take a look at another question. And again, the biggest thing with these are just going to be the inequality pieces of it. Just be careful to write down what the possible values are. So once again, find me a number. I see 12. Do I see anything else? No. So 12, on the left of 12 will be what it is or a keyword. And I see no less than 12. So let's talk about that. I have no less than 12 things. Nothing less than 12. No less. No less. Nothing less than 12. Can I have 13? Yes, because I said I have no less than 12. So I can have 13. All right. Can I have 11? No, because it said no less than 12, and this is less than 12. Can I have 12? Yes, because it just says nothing less than 12, but I can have 12. What's the direction that I'm going in? I'm going this direction right here. Okay, so if you look at your inequality head, it's right there. That's what it looks like. And because I'm including 12, I'm going to put the or equal sign. All right, so it says write an inequality to represent the possible values of the number of drinks D, so it's drinks, and the number of possible candies C. So when I put together my C plus D, it's going to be greater than or equal to 12. So the drinks that I purchased plus my candy has to be no less than 12, and that's your inequality. So C plus D no less than 12. Next one we're going to look at is write a system of inequalities word problems. So in order to answer this question, you actually have to write a system. They don't grade you on that. They grade you on your solution. But we're going to practice quite a few of writing the system first. All right, so again, your first thing is to find all the numbers. So you got the number right there, the number right there. Let me go ahead and highlight them. And on your computer, you actually have something where you can highlight as well, so that way you're highlighting the words and making it easier for yourself. So I see $1.50. What is $1.50 referencing? It's usually on the left-hand side. So this is selling apples. I see $1. What is $1 referencing? On the left, it's talking about peaches. $20. It says Adil has $20 to spend. Okay, so this one is on the right, right? I have 20 to spend. All right, 15. Okay, on the left side, the keyword is minimum. 4. All right, you decided to buy 4. Oh, this is a question. So at this point, the question happens. Okay, so first I write my inequality, then I answer the question. So that's the question. All right, so I have how many numbers? 1, 2, 3, 4. Because I have 4 numbers, it is 2 sentences, not 1. All right, so because I have 4, this is the one I look for. Money, money, money. Money, money, money. So I'm just going to circle the money, money, money. So money, money, and money. So those 3 numbers go together, and this one is x plus y is 15, or whatever they tell you. So they don't actually tell you what to choose, so I'm going to choose x for in order. X is going to be apples, y is going to be peaches. Okay, so let's put it together in a sentence. You have x is $1.50 plus y, which is $1. And then I have 20 to spend. Okay, so what's the inequality with saying I have 20 to spend? Well, think about it. Your mom gives you money to go to the mall and says, here, you have 20 bucks to spend. All right, so can you spend $20? Yes, she just said you had $20 to spend. Can you spend $21? No, she did not say you can spend more than $20. So you cannot have 21. Can I spend $19? Yes, because she said, hey, you have 20 bucks. So if it's less, that's cool. If it's more, no. All right, so looking at my tick marks, I am going in this direction. Again, the arrow tells you the inequality, and all you have to ask yourself is, do I include the 20? Because it's a tick mark, I say yes, so this is less than or equal to. So this is less than or equal to, which means this first sentence is less than or equal to. Now that I have used all 3 of these numbers, I cannot use them again. The only other number I have is 15. The keyword I have is a minimum. So I'm going to start with, I have a minimum of $15. A minimum of $15. All right, a minimum. Another way of saying I have a minimum is I have at least $15. All right, the least amount I have, minimum, the least amount I have is $15. All right, so can I have $15? Yes, because that's the least amount I have, the minimum that I have. Can I have $16? Yes, because again, the least I have is 15. So I can have more, but I just can't have what? Less. So I cannot have 14 because the least that I have is 15. So looking at that, my arrow is going this way. So this, my inequality, and because I included 15, it's greater than or equal to. So this one is greater than or equal to. And because I have used all the numbers now, there's nothing else. It's just the apples and the peaches have to be a minimum or more than or equal to 15. So those are my 2 inequalities. So the question isn't really asking you to write the inequalities, but you need to write the inequalities in order to see the solutions. So I'm going to transfer that into my calculator so that I can see my solutions. All right, so I'm going to copy it exactly. All right, once I've copied it into my calculator, I'm going to double check to make sure it matches, and it does. So this is good. I'm good. So here's my solutions anywhere in here. And because this is a real world problem, be careful because I can't have negative apples or negative peaches. So I wouldn't be on the left side. But let's see what the question is now asking. So that's my inequalities. If I decide to buy 4 apples, okay, so, and again, according to what I wrote, apples is X, right? Apples is X. So what they're saying is X is equal to 4. Okay, so if you decided to buy 4 apples, what are all the possible values for the number of peaches you could buy? So what it's asking is, if I'm buying 4, which is anything on this purple line, where are my solutions there? So it's anything here where the purple line is with my solution set. So I'm going to really zoom in to where it's going up by 1. Because can I buy 4 apples and 11 peaches? Yes, because this is a solid line. So I can have 11. And I'm not sure how to put these answers in. So I'm just going to press plus and see if this is it. Or I can have 11. Can I have 4 apples and 12 peaches? Yes, it's in my solution. So I can have 12. All right, so I'm going to add another one. Can I have 13. Yes, it's in my solution. So 4 peaches and 4 apples and 13 peaches. And then can I have 14? Yes, because this is a solid line. So that's going to be 14. Can I have 15? So can I have 4 apples and 15 peaches? No, because now I'm not in my solutions. So these are all the possible values that I could have. 11, 12, 13, and 14 peaches. So again, the key is you got to write the inequalities, put the inequalities in graph, look at your solutions, then based on what they ask you, see what's possible. All right, so we're going to take a look at another question. All right, so Charlotte is working 2 summer jobs. Find my numbers. So here's 7. She's making $7 washing. Okay, so this one is after. So she's making $7 washing cars. She's making $19. There's another number, tutoring. In a given week, she can work at most 16 total hours. So that's 16 at most. She must earn a minimum of 220. So that's 220 minimum. So I just need the numbers with the keyword. Everything after that is the actual question once you write the inequality. So we have 4 numbers, which means 2 sentences. Once again, when you have 4 numbers, you're looking for money, 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 or you're looking for calorie, calorie, calorie. Okay, so it just depends on what the situation is. A lot of the questions are money, money, money. It looks like this one is money. So I'm going to circle all my monies because that goes together. So money, money, and money. Those numbers go together. That's my sentence. All right, so let me look at my keywords and make my keywords. Let's start with the minimum. I have a minimum of $220. So I start off with $220. This is my minimum amount, the least, the minimum, the least amount of money. The minimum number I have is 220. I can include that because that's the least I have. All right, can I have 221? Yes, because the least I have is 220, so I can have more than that. What about 200? All right, can I have 200? No, because it says the minimum I have is this one. The least I have to have is this one, so I can't go below that. So again, draw your arrow. Which way is it going? Looking at the head, it's going to the right. And because I can have 220, I can say or equal to. So this one is going to be greater than or equal to. The other one is going to be 16, and it says at most. So at most, so now we talked about the least or the minimum, but now it's the at most. At most, I can have $16. Can I have 16? Yes, because that's the utmost, the most, the maximum I can have. Can I have 17? At most, I can have 16. Can I have 17? No, because it's saying the maximum or the most I can have is 16. Can I have 15? Yes, because at most I can have 16. The maximum I can have is 16. So I can have less than that as long as I don't go over 16. So draw your arrow again. So it's going this way. All right. Look at your arrowhead. And now, do I include the 16? I do. If I do, I put the or equal to. So the at most means less than or equal to. All right, now that I have that, let's write out our 2 sentences. So I've circled my money, money, money. Let's go ahead and put that in order. 7 washing cars. And again, because they didn't tell me, I'm going to use the first one as X. So I'm going to put this one as X and this one is Y. So 7X plus, what's my next number? 19. Y. Okay, and then the last number is minimum of 220, which means greater than or equal to 220. So I have used this, this, and this. Okay, so the only thing left is 16. So I'm going to go ahead and put that in. So 16, and we know that's less than or equal to, but I need to make my sentence. How do I complete my sentence? I go X plus Y. All right, once I have my 2 sentences or my 2 inequalities, I just need to go ahead and put that in the calculator so I can see what my solutions would be. All right, so again, once you type it into the calculator, here's your solution where they overlap, where black overlaps with red. And again, be careful because it's a real world situation. Sometimes you can have negative whatever it's asking for. So here's my solution where they overlap. Now I'm going to go and read the question. It says, if Charlotte worked 11 hours tutoring. So I need to know, is tutoring X or Y? According to my notes, 7 X was washing cars. 19 Y was tutoring. So Y is equal to 11 because you want to be tutoring. So Y is equal to 11. That means within my solution, wherever this blue line is, is what I'm looking for. So in this case, I'm looking for what is the minimum number. Okay, so the smallest number. So what is the smallest number here where I'm washing cars? Okay, so can I have negative, what does that say? Hold on. Can I have 1.57 cars? No. So this is hours. So can I have decimals as hours? I can actually. If Charlotte worked 11 hours tutoring, determine the minimum number of whole. Okay, so that did finish reading. Whole hours that I can do. So I can't do 1.5 because that's not whole. So what's the next whole hour? 2. Let me zoom in. All right, so the next whole hour would be 2. So I can work 2 hours washing cars, 11 hours tutoring. Okay, so again, just be careful to read the question because this said whole, because I was going to say you could actually have this as a solution. You can have 1.57143 hours, but because it says whole, you have to go with that. So 2. This is only asking for the minimum number. So I'm going to put the minimum that I can have, which is the smallest I can have, which is 2. All right, so we're going to take a look at simplify algebraic square roots. You're going to start every single time by typing the question into your calculator so you can check your work as you're doing it. This is how you get the power, this button right here. And then y to the 5th power. Okay, so you type in the question. Now you're seeing there's an error. What does it say? Try adding an equal sign to turn this into an equation. Do not add it in the middle, add it at the very beginning. You need something on both sides. Okay, so usually we put a y. So I just need a y equals and then your equation. And what we're doing is matching this shape the entire time. Okay, so this is what we're trying to get to match. If I do this correctly, Control C, Control V, it's going to match every time. So all my work gets done here. As soon as I see my mistake, I stop and correct it. All right, so simplify this radical. All right, so let's start by breaking down the number. So we have the number 8. You say you're going to divide it by 2. 8 gets replaced with 2 times 4. So 8 gets replaced with 2. And you see, because I only replaced it with 2, it's off. But as soon as I see times 4, we're back okay. So again, we're checking it every single step. Now I'm going to go with the number 4. And then again, I'm going to check divided by 2. 4 gets replaced with 2 times 2. 4 gets replaced with 2, and again, you see something's wrong, times 2. I'm back okay. All right, so all we're doing is breaking it down. All right, what does x to the 5th power mean? That I have 5 x's. And again, as soon as I take that out, you see it's changed. I need to say x 5 times. 1 times x2 times x3 times x4 times x5. Now you see we're back matching again. So all I'm checking is every single step, I'm making sure that I'm doing it correctly. What does y to the 5th power mean? That I have y multiplied 5 times. So I'm going to have 1, 2, 3, 4, and you can see I'm not matching yet. 5, I'm back matching. All right, so since I'm back matching, this means that I have broken this down correctly, and I'm going to make this bigger so we can use it. All right, I've broken this down correctly. And all I have to do now is take out books. If you're in a different class for you, you're taking out twins, right? Why is it twins? Because when there's no number here, it's automatically 2. So you're looking for twins, but if you're in my class, you're looking for books. All right, so do you see any books? Do you see any twins? Yes, I see a book of 2 or a twin of 2. When 2 people in the house who look very different to their mom walk outside and they're twinning, right? To the rest of the world, they look like one person. For me, 2 cards make a book. All right, do you see any other books or another twin? Yes, I do, right here. 2 cards make 1 book. And every time I put it in, I'm double checking that my graph comes back. 2 cards, I'd see another book right here. 2 cards make 1 book. Every time, you see, it comes right back. All right, do you see anything else? I do. 2 cards make 1 book. And every time I replace what I'm doing, you see it comes right back. All right, so I'll say it in the other lingo if you're in another class. 2 people who are identical, look exactly the same, right? When they leave their house and go outside to the rest of the world, they look like one person. Yeah, so that's what we're doing. So far we're matching. Any more twins in here? Anyone who looks exactly alike? No, so that means we're done. Now we just have to simplify everything. So I can combine these two, Control C, Control V. 8 times 2 is 16. So I'm going to go ahead and do that. Again, I put 1, I'm mismatching because I said 16. So that's okay. All right, how many x's do I have? I have 2 in total. How do I write that with exponents? X to the power of 2. So again, I only have 1 x now, mismatching. I come right here, power of 2. I'm back matching again. How many y's do you see? 2. So I need to combine those. So again, I delete 1 y and look, that's not matching. I put the 2 back and I'm good. Okay. Can I combine anything else in here? No. So I'm done. Now that my problem has completely matched, I am 100% sure that I am right. And now I copy it into my answer key or into my answer. So this is 16x squared. So shift 6, or you can hit the keypad right here and do squared. So it looks this the same as decimals, honestly. And then y squared, then square root, not cube root, but square root. 2 cards make a book, 2xy. We're going to take a look at simplify algebraic cube roots. So cube roots mean 3 cards make 1 book. 3 cards make 1 book. I'm just trying to find a complicated one. That looks kind of complicated. All right, so again, type it into the calculator. So I have 4x. How do I get cube root? Or 4x to the power of 3. All right, then bring it down. How do I get cube root? I press functions, scroll all the way to the bottom, and then this is the button right here. And then we're going to put a 3 over there. And then inside I should have 54x to the 5th power, y to the 7th power. Careful with what you're typing. You need to click out or right arrow, y to the 5th power. All right, so again, always double check. Oh, that's 5th, should be 7. Double check what you are writing to make sure it matches with the question. All right, again, there's an error because it needs an equal sign. We're going to put that in the front. Again, there's still an error because you need something on both sides, so we're going to put a y equals on the front. Once you have your graph, you're going to Control C, Control V. And I think you're going to be able to do that on the interim. I'm not sure. If not, you got to copy it twice. Zoom out so you can see it nicely. So blue and green are going perfectly over each other. I think on the cube roots one, it changes at the end, but I'm going to talk you through that. So again, now once I'm matched, I don't need the question, so I'm going to make this bigger so I can do it. 3 cards make a book. So we're going to start with breaking down what's in my hand. So 54 divided by 2. Yes, that works. So 2 times 27 replaces 54. So I'm going to go to 54, 2. Again, see how that doesn't match because I need times 27. I'm back matching. Now I'm going to go to the big number, 27, and I'm going to check 2 again. Does that work? It does not. So I'm going to check 3. That works. So 27 gets replaced with 3 times 9. So 27 gets replaced with 3 times 9. Back matching. All right, now I'm at 9, so I'm going to use 9. I already checked 2 doesn't work, so I'm going to check 3. Yes, it does. So 9 gets replaced with 3 times 3. So 3, not matching because I need times 3. Perfect. All right, 3 is a prime number, so I can't break it down anymore, so I'm done. All right, let's break down x to the 5th power. What does that mean? X times x times x times x times x 5 times. So that's what I'm going to do. Again, we're mismatching. I need to write x times x times x times x times x, and I'm back matching. And I'm just going to put the times here too. All right, then I need how many y's? 7 y's multiplied together. So now I'm back unmatching, and then I go times y 1, 2, 3, 4, 5, 6, 7. Back matching. All right, so now it's broken down completely. I just need to make books. How many cards make a book? 3. If you're in other classes, how many people look the same outside? Triplets. You're looking for triplets. They look different inside the house because mom knows them, but when they leave the house, they look like the same person. Everyone confuses them for the same person. All right, so in my case, 3 cards make a book. Do you see a book? Do you see a triplet? I do. Right here, I got 3 people that look exactly the same. I got 3 cards that make 1 book outside, and I'm put it in the front. So 1 book outside. Now, what's my problem? Because I put the book outside or I put the triplets outside. Why is this not matching? Because I've changed the number into 34 instead of 3 times 34. So as soon as I put the times back, we're back matching. So just be careful. All right, do you see any more triplets or any more books? I do. So 3 cards or 3 people, 3 triplets make 1 book outside. So I'm going to put an X outside. So times X. And I'm back matching. Do you see any more books? I do. 3 cards make 1 book. So I'm put it over here, but not up there. So I need to bring it down. Y. I'm back matching. 3 cards, right? Or a triplet makes 1 outside. All right, I'm back matching. Any more triplets in here? Nope. So I'm done. So the last step is just combining everything. So I'm going to start with this. 3 times 4 is 12. So this is going to become 12. Am I okay? Yes, I am. How many x's total do I have? So I have x here, and then I have x to the 3rd power. What does x to the 3rd power mean? X times x times x. So I have 3 of them plus this other one. That's going to be how many total? 4. So this is x to the 4th power, and I'm back matching. All right, then over here, now be careful because this one is not attached to this. This is cube root. If you want to think of it, you can think of it as space. In fact, let me do that so it's very, very clear. This is cube root. So how many y's do I have? 2. How do I write that as exponent? Y to the 2nd power. And I'm back matching. Again, without it. Okay, and this is where, okay, so on cube roots, it looks a little weird, but you can see it's not matching there. And then when I put the second one, it does. All right, so that's done. Now I'm going to go inside. What can I combine here? How many x's do I have? 2. How do I write that in exponent form? X squared. And again, you see I'm back okay. All right, nothing else to combine, so this is my answer. So now I'm just going to go ahead and write it in. So 12x to the power of 4, y to the power of 2, cube root 2x to the power of 2, and then a y. Double check that you copied it correctly because you already know it's right in here. So make sure you don't get it wrong because you're miscopying. And then you can click submit. All right, the last one I'm going to take a look at is the sum and product of rational and irrational numbers. All right, so we're going to look at different types. So there's a sum and then there's a product. So I'm going to do sum first and then we'll do product second. So sum, find the sum. What does sum mean? Add. So it's saying add these 2 together. So let's go ahead and type that in. So 4 square root of 9 or 4 radical 9 plus, because it says sum, 3 radical 10. All right, now this time there's no graph, you're matching the numbers. So I'm going to copy this, put this here. So now it's matching, and this is where I'm going to work for. So we always start the same way. I cannot add until they look the same. So this is like when you were in 2nd grade and you had 2 apples. That is not how you spell apples. 2 apples plus 3 apples. What would you say, tell the teacher you have? 5 what? Apples. Okay. Then when you get to 5th grade, you're not talking about fruit anymore. You talk about x's. So I have 2x plus 3x. How many do I have? 5x. Okay. So you see it matches, right? So now we are in 9th grade. We're talking about radicals. You cannot add them until these radicals are exactly the same. All right. So square root of the same exact thing. So to check to see if they can become the same is you're going to break down each one. So let's start with 9 divided by 2 doesn't work. Divided by 3, that does work. So I can replace 9 with 3 times 3. All right, something is wrong because I typoed 9, right? So boom, I'm back okay. All right, can I break down 3 anymore? No, because that is a prime. So now I'm going to go to 10. Check 2. That works. So I can replace 10 with 2 times 5. Can I break down 5? No, because that's a prime number. So I'm still matching. I'm still okay. All right, now 2 cards make 1 book, or if you're in a different class, twins make 1 person outside. So do you see any books / twins? Yes. I see a book of 3s, or 1 set of twins. So 2 cards make 1 book. Okay, now there's an error. Why? Because it's saying that radical cannot be empty. Because there's nothing there, we can just go ahead and do what to it? Delete it. So I'm still okay. Do you see any books here? No. So once you don't see any books, the last step is to combine what you can. So 4 times 3 is 12. But if you don't know that, you put that in the calculator. So that's going to be 12. And then combine inside. 2 times 5 is 10. But if you don't know it, put in the calculator. That's going to be 10. Now again, I'm now at the 9th grade. Can I combine these two? Do you see radical 10 on both so I can just add them? No. So this is the final answer. So 12 plus 3 radical 10 is your answer because it's still matching. Is this rational or irrational? Well, let's look at the decimal. Is it terminating? Does it end? No, because even though it looks like it ends right here, it doesn't, because decimals doesn't want to write it forever. So does not end, does not repeat, is not a fraction of integers, therefore. All right, so now we're going to look at product. All right, so what does product mean? It means multiply. So what is the product of these two? So type it in. Oops. Okay. 5, double check that you make sure that you did it correctly. All right, and then again, when you're looking at product, when you're looking, oh, I did plus, it's supposed to be multiply. All right, so product is multiplication. Oh, and I don't have to do anything here because it simplifies to a whole number. So this is 220. All right, this result is rational. Why? Because I can write 220 as a fraction of whole numbers, of integers. All right, so it can be written as a ratio of 2 integers, and its decimal expansion does terminate or repeat. It ends at 220. All right, so again, the word product means multiply. So type it in, 4 radical 3 times 4 radical 21. All right, do it twice so that you can work on one and stop as soon as you make a mistake, if you do make a mistake. All right, so this is my answer, but I can't write it as a decimal. I have to write it as a simplified radical. Remember, multiplying is just the same as simplifying, but the thing is, you just need to put it, you need to have one radical. So we need to combine this somehow. And the rule to combine is anything outside is outside, anything inside is inside. So we're going to start with the outside. I'm going to put the outside where? Outside. So I just need to make it one radical. Then the inside where? Inside. Okay, delete this. Now it's one radical and I'm still matching. So once again, when you're multiplying radicals, outside with outside, inside with inside. All right, once you have that, you're going to break it down. 3 is as broken down as you can. So I'm going to start with 21. 21 divided by 2, sorry. 10.5, that does not work. So divided by 3. 3 times 7 works. So 21 gets replaced with 3 times 7. And you can see we're still matching. Can I break down 7? No. So that means I'm done. All right, how many cards make a book? 2 cards make 1 book. Or if you're in a different class, you're looking for a twin because there's an invisible 2 right here. So do you see any twins? I do. So those 2 people, those one set of twins, go outside the house and they look like the same to everybody else. Okay, 2 cards make 1 book. I'm still okay. Any more books in here? Nope. So I'm done. So all I have to do is simplify the outside, which is 48. And then simplify the inside, and it's just 7, so there's nothing else to simplify. Am I still okay? Yes. All right, so this is my simplified result is going to be 48 radical 7. And now we're going to look at it. Is this a fraction of integers? No. So this is going to be irrational if it doesn't terminate or repeat. Does it terminate or repeat? Nope. So this is irrational. So it only has to do one of the three things. Either it's a fraction of integers, it terminates, or it repeats. So this is irrational because it cannot be written as a ratio of two integers, and its decimal expansion does not terminate, nor does it repeat. All right, so let me go ahead and do another example. So again, we're going to do another product example. All right, so we've got 4 radical 6 times, because it says product, radical 10, or square root of 10. Again, you copy it down twice. All right, so that's the same number. When you're multiplying radicals, you just need one radical. And the rule is outside with outside, inside with inside. So there's nothing out here, but there is something inside. So this inside also goes in here. Now, if I did it that way, what do you notice? Something is wrong, because I didn't say it's 6 times 10. I said it's 610. So please be careful to make sure that you understand its multiplication. All right, so we're going to break down 6. So check 2. That works. 2 times 3 replaces 6. So 2 times 3. Now we're going to check 10 divided by 2. That works. 2 times 5 replaces 10. Okay. Now we just need to make cards. And again, they don't have to be in order. So remember, when you pick up your cards, they're not in order, right? Do you see any books? 2 cards make a book because it's a square root. Yes, I see a book of 2, so I'm going to delete that 2 and delete this 2, and that makes 1 book outside. Okay, so now you have no more books, so we'll combine everything. Combine the outside with the outside, so 4 times 2 is 8. Combine the inside, 3 times 5 is 15. But if you don't know, you just copy and paste into the next line. The calculator will tell you. All right, am I still okay? Yes, I am. So this is my simplified answer that I'm going to put it over here. 8 radical 15. And again, what I'm looking is, do you see the fraction? No. Looking at the decimal piece, is it repeating or terminating? No. So this is going to be irrational, because you cannot write as a ratio of integers, and the decimal expansion does not terminate or repeat. Let's practice.